Hello students, welcome to Brilliant Qatar. D and F block elements 100 MCQ. Let's discuss in this session. Those who are seriously preparing for the upcoming 2025 chemistry board exam, please be here. Let us discuss the most important 100 MCQ in which let's discuss the entire theory of the chapter D and F block elements. You know, it's one of the inorganic chapter. Mostly they ask you reasoning questions from this one. Ready? So question number 1, let us start from the 2024, the previous year board question from D and F block is here for you. The correct order of the increasing oxidizing power of the 3D series of transition element is. See all, increasing order of oxidizing power. Dear, oxidizing power, if they ask you, check the oxidation state first. What is that? Oxidation state of that central metal atom we have to identify. Higher the oxidation state, higher the oxidizing power. So MnO4 minus, let me calculate Mn, what is the oxidation state? Mn we don't know directly, let me take it as X. One oxygen charge we know -2, so 4 oxygen charge is -8 and overall charge is -1, X equal to what? +7. So in MnO4 minus, what is Mn charge? +7. Next, Cr2O7 2 minus, let us check it. What is the charge of 1 chromium? So 2 chromium is there, therefore 2x. 1 oxygen -2, so 7 oxygen -14 and overall charge is -2. So 2x equal to 12 and x equal to what? +6. Here chromium is in +6. What about vanadium in VO2 plus? Vanadium X and 1 oxygen -2, so 2 oxygen -4 and overall charge is +1. So x equal to what? +3. Greater the oxidation state, greater the oxidizing power. So which one having greatest oxidation state, my dear? This one. So this is the highest and this is the same order. That is MnO4 minus. MnO4 minus having the greatest, okay? MnO4 minus having the greatest. Then Cr2O7 2 minus least one. So option C. This is the 2024 board question they were asked. Ready? I think the question is clear. Let us go for second question. Which of the following has magnetic moment value 5.9? What is the equation for magnetic moment? Nu equal to root of n into n plus 2 Bohr magneton. Yes or no? Where what is n? N is the number of unpaired electron. N is the number of unpaired electron here. So if you want to get overall magnetic moment 5.9, if you want to get overall 5.9, what should be the value of n? N should be 5. So 5 into 5 plus 2, what is equal to? Root 35. You know, root 36, that's 6. Root 35 is what? 5.9. Near 5.9. So root 35 if you want to get, or 5.9 if you want to get, how many unpaired electron should be there? 5 unpaired electron. Check it all where you have 5 unpaired electron. You know, Fe atomic number is what? 26. Fe atomic number 26, right? So what is the configuration we have? Argon and 4s2 3d6, right? Argon is 18. Next 2 electron in 4s, remaining electron in 3d. Fe2 plus means what? Fe2 plus means these 2 gone. So what is 3d6, right? What do you mean by 3d6? 6 electron. 1, 2, 3, 4, 5, 6. Here there is only 4 unpaired electron. We need 5. So answer is which one? Fe3 plus. Because Fe3 plus mean 2 electron go from here, 1 electron go from here. What it will be? 3d5. What do you mean by 3d5? Yes, there will be 1, 2, 3, 4, 5 unpaired electron. So if the system having 5 unpaired electron, what is the magnetic moment? Root of 5 into 5 plus 2, root 5 into 7, root 35, that's equal to 5.9. Ready? So answer is option B. Question number 3. Anomalous electronic configuration is in 3D series. What is 3D series? Remember, mostly they ask you question based on 3D series. What are 3D series element? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. They are 3D series compulsory to know. All right. So in 3D series, we studied where is the special anomalous configuration, that is chromium and copper, right? Chromium and copper, because chromium is half field stabilized and copper is fully field stabilized. Yes, right? Question number 4. Which of the following D block elements are D block element? They are D block element but not transition element. If it want to be transition element, what is the condition? If it want to be a transition element, that should contain incompletely filled d orbital either in their ground state or in their oxidation state. You know the set of element zinc, cadmium and mercury. Yes dear, zinc, cadmium and mercury, they are in the same group. They are in the same group. And zinc atomic number 30. What is the configuration? You will get 4s2 3d10. And cadmium, that is 5s2 4d10. And mercury 6s2 5d10, like that. So see, their d orbital is what? Fully filled. D orbital is fully filled. D orbital is fully filled in their ground state or in oxidation state. What is their oxidation state? 2+. If you take it 2+, this will go and remain also. D orbital is fully filled. If D orbital is fully filled, that what we can call, they are not considered as transition element. So zinc, cadmium, mercury, they are in D block, but they are not transition element. Ready? Next one. Transition element form alloys. What do you mean by alloys? It's a mixture of what? Two or more metal or metal and non-metal, right? So transition element form alloy easily because it's a question for exam. Why transition elements form alloys? Dear, the answer is they have nearly same atomic size. Because they have same atomic size, one metal can replace by another, so they can form a homogeneous mixture. So due to the similar size, they form what? Alloys. Ready? Question 6. Which of the following characteristics of the transition metal is associated with a higher catalytic activity? You know, transition metal used as catalyst because the main two reasons are there. Because they shows variable oxidation state and they provide large surface area. So what is the answer? They show variable oxidation state. Therefore, they shows catalytic activity. Which of the following has the maximum number of unpaired electron? Maximum. Let's see manganese. What is manganese atomic number? Manganese atomic number is 25. So we can write it as argon 4s2 3d5. Ready? What do you mean by Mn2+? 2+ mean 2 electron loss. What is left? 3d5. 3d5 means how many unpaired electrons here? There will be 1, 2, 3, 4, 5. 5 unpaired electrons will be there. All right. So titanium, check it. Titanium atomic number is 22. Scandium, titanium, right? 22, how we write? Argon 4s2 3d2. And if titanium 3+ mean 3 electron lose. 2 from here, 1 from here. Only 1 unpaired electron here. You can check it, the other element. Vanadium atomic number 23, iron atomic number 26, you can cross check it. The maximum unpaired electron you can see 5, that is in Mn2+. Fe2+, I think we already discussed that also, right? Yes, there is 4 unpaired electron. So Mn2+ is the one having among this one highest number of unpaired electron. Question number 8, the property which is not a characteristics of transition metal, not a property. Variable, yes, they shows variable oxidation state, tendency to form complexes, yes, formation of colored complexes due to DD transition, yes, non-metallic, no transition elements, right? They are metal, they are metallic in nature, they are not non-metallic. Now, lanthanide contraction is caused by an increase in, what is lanthanide contraction? It is a steady but slow decrease in atomic size along the lanthanide series with increase in atomic number due to increase in effective nuclear charge. So, lanthanide contraction is caused because of what? Effective nuclear charge, due to effective nuclear charge. Now, which group of elements do transition elements belong? Simple question. Which all are our transition elements belongs? D block element, right? Transition elements belongs to D block elements. Question 11. Which of the following is diamagnetic? Diamagnetic means what? No unpaired electron. No unpaired electron. Let us see. Cobalt atomic number. So I think let us go for the direct answer here. We already discussed that. Zinc. Because Zn atomic number is what? 30. 30 means what is the configuration? Argon 4s2 3d10. Here Zn 2 plus, right? 2 plus means this 2 electron goes. What is left? D10. D10 mean what? Fully filled. There is no unpaired electron. So no unpaired electron or diamagnetic means which one? Zn 2 plus. Question 12, which of the following is not a part of the first transition series? You know the first transition series element, right? Can you say scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc? Which is not belongs to this one? Magnesium. Magnesium is in S block, right? It's a metal, right? Now the color of transition metal, very simple. Why? What is the reason for the color of transition metal? DD transition. Yes, all of you, DD transition. The unpaired electron make DD transition and they shows color. Now the melting point of copper is greater than that of zinc because, see, copper atomic number 29, you know there is an exception in configuration, that is argon 4s1 and 3d10. This is the configuration. What about melting point of copper? What about the greater than that of zinc? Zinc, the atomic number is 30. So what we write? Argon and 4s2 3d10, right? Ready. Now question, why the melting point of copper is greater than that of zinc? See, what is the reason for melting point? See, if that contain more number of unpaired electron, if they're in the system, they form very strong metallic bond. Stronger the bond, they have what? High melting point, right? High melting point and high enthalpy of atomization. So why copper? So zinc, see, there is no unpaired electron, but copper in 2 plus you consider. Copper can exist in different oxidation state, right? Copper plus 1 is there, copper 2 plus is there. You consider copper 2 plus. What do you mean by copper 2 plus? 1 electron go from here, 1 electron go from here. It will be 3d9. 3d9 means there will be unpaired electron. Yes, one unpaired electron is there. But in zinc, there is no unpaired electron, so they form very weak metallic bond, so their melting point is very less. So we can say the melting point of copper is greater because the number of unpaired electrons are take part in bonding, which form very strong metallic bond. Copper has BCC, no. Copper has large, no. Copper electrons are involved in metallic bonding. Stronger the metallic bond, higher the melting point. Next one. The zirconium and hafnium. Here where we studied zirconium and hafnium, we know 3D series, 4D series, 5D series, right? In 4D series zirconium, 5D series hafnium, if there, we know 4D and 5D series element shows almost similar atomic size. That is because of lanthanide contraction. We studied the consequence of lanthanide contraction. 4D and 5D series have almost a similar size. Because of that, zirconium and hafnium shows almost a similar property. So zirconium and hafnium have almost equal atomic and ionic radii. That is because of what? Lanthanide contraction. It is one of the consequence of lanthanide contraction. Electronic configuration of a transition element X in +3 state is given as, that is argon with what? 3d5. Argon and 3d5. What is the atomic number? So electronic configuration of a transition element in its +3 state is given. Okay, +3 state is given to you. What is argon? 18. So 18 plus 5 is equal to 23, right? But it is in their +3 state. What do you mean by +3? Already 3 electron loss. So before, what it was, 3 will be there, 26 electrons will be there in the system. See, all they given the element in +3 state, it is having how many electron? 23 electron. Because +3 state, what is the configuration given? 18 and 3d5. 18 and 3d5. That means the 4s electron, everything is gone. So plus 3, if they ask plus 3 mean already 3 electron loss. After losing 3 electron, how much it's having? 23. So before leaving that 3 electron, how many will be there? We need to add 3. So that will be 26 electron in that. So what is the atomic number is the question. Atomic number will be what? 26. Next question number 17 for you. Metallic radii of some transition elements are given below. Which of these elements will have highest density? You know, density related to what? Density mainly depends on what? Mass by volume, right? Density directly proportional to mass. If you go from left to right, what happened? You know, atomic number increases, right? Electrons are getting added, right? So when you go from left to right, the mass increases, so density increases. Which one is the element present? See, the element scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel and copper. Copper is at the last. Copper is at the last. When you go from left to right, what happened across a period? Atomic mass increases. So what happened? Density also increases. So copper having the greatest density. Alright. So metallic radii actually is given here 126, 125, all nearly same and all given. Anyway, the main factor affecting what? Density is what? Density, it is increases when the atomic mass increases. From left to right, it increases. Now, the magnetic nature of elements depend on the presence of unpaired electron. Yes. Identify the configuration of transition element which shows highest magnetic moment. What is the equation for magnetic moment? Nu equal to root of n into n plus 2, right? What is n? Number of unpaired electron. More number of unpaired electron is there, more magnetic moment. So you check where we having more number of unpaired electron. So 3d7, what do you mean by 3d7? 3d7 means 1, 2, 3, 4, 5, 6, 7. So how many unpaired electron? 3 unpaired electron. What about 3d5? Yes, there will be the maximum 5 unpaired electron. 1, 2, 3, 4, 5. Yeah, 5 unpaired electron. What do you mean by 3d8? 3d8 means how many unpaired electron here? 1, 2, 3, 4, 5, 6, 7, 8. Only 2 unpaired electron. d2 means only 2 unpaired electron will be there, right? So 2. So which one having greatest number of unpaired electron? That's having greatest magnetic moment, that is 3d5. Now, which of the following oxidation state is common for all lanthanoids? Lanthanoids and actinoids, there is a common oxidation state or general oxidation state, that is what? +3. Please remember dear, lanthanoids, okay, lanthanoids group shows a common oxidation state as what? +3. Which of the following reaction are disproportionation? What do you mean by disproportionation? Same species undergo both oxidation and reduction called disproportionation. Check it. Copper, here it is +1 state. Copper, here it is +2 state. And here it is 0 state. So copper +1 converted to +2. What is that? +1 converted to +2 means oxidation. +1 converted to 0 means what? Reduction. So both oxidation and reduction takes place mean yes, it is disproportionation. So first is disproportionation. What about MnO4 2-? What is the charge of Mn in MnO4 dear? We can take it as Mn is X and 1 oxygen -2. So 4 oxygen -8 overall -2. So X equal to what? +6. So here Mn is what? +6. What about here Mn? MnO4 minus mean Mn is in +7 state. Yes or no? Because Mn is X. 4 oxygen -8 and overall equal to -1 and equal to +7. And here MnO2 mean Mn will be +4. See all, +6 converted to +7. What is that? +6 converted to +7. Increase in oxidation, right? That means oxidation. +6 converted to what? +4. That is what? Reduction. Yes, so that is also a disproportionation reaction. What about this case? KMnO4. KMnO4 manganese is in +6 +7 oxidation state. In K2MnO4 you calculate Mn will be +6 state. MnO2 it will be +4 state. Alright. So here you just analyze +7 converted to +6, right? Decrease means what? Reduction. +7 also converted to decrease, reduction. That is not both oxidation and reduction. Both are reduction. So it is not disproportionation. And here you observe only one manganese here. Okay, let us check it. Here Mn is +7. All right. Here Mn is already +2. And here it is what? +4. Right? +4. Is it oxidation or reduction? Can we say that here? No, that is only 1 and 2 is possible, right? So 1 and 2. So what is the basics idea? If an element, if same species undergo both oxidation and reduction, then what it is called? Disproportionation reaction. 21. Gadolinium belongs to 4F series. Atomic number is 64. What is the correct electronic configuration? Here, gadolinium 64 means we can use xenon configuration. What is xenon atomic number? 54. What is other 3 orbital? We have 4f, 5d and 6s. After 54 xenon, what is the orbital we have? 4f, 5d, 6s. Do you know the filling of electron? The way of filling of electron is like this. Let's have understanding. After 54, next 2 electron we should fill here. 1 electron fill it here and 14 electron we have to fill it here. Basics. After 54, 2 electron here, 1 electron in 5d, 14 electron in 4f. If you have some more electron to fill, come back to 5d, fill up to 10. So here we need to fill 64, right? Already 54 over. So 10 more electron we need to fill it. Okay, let us fill 2 here, 1 here, 7 here, right? That is the configuration. So it's xenon, 4f7, 5d1, 6s2, that option A itself. 22. Interstitial compound. What are interstitial compound? In the transition metal, the small gaps are there. That's called the what? Interstitial site or void. Where small elements like carbon, hydrogen, oxygens are trapping, they're called interstitial compound. Interstitial compounds are formed when small atoms are trapped inside the crystal lattice. Which of the following is not the characteristics property? You may study 4 properties of interstitial compound. They are very hard. They have very high melting point compared to the pure metal. They retain their metallic conductivity and they are chemically inert. So they have high melting point as compared to pure. Yes. They are very hard. Yes. They retain their metallic conductivity. Yes. They are chemically very reactive. No. Interstitial compounds are chemically inert. All right. D. Next one, KMNO4 act as an oxidizing agent in alkaline medium, even acidic and neutral, every medium. When alkaline KMNO4 is treated with a Ki, the iodide ion is oxidized too. Please note it, all of you. If your medium is KMNO4, if the oxidizing agent is KMNO4, in acidic medium, the iodide converted to I2, and in neutral or faintly alkaline medium, the iodide converted to iodide IO3 minus. All right. So in KMNO4, in alkaline medium, convert iodide to what? IO3 minus iodide. That is option C. All right. So in acidic medium, I minus converted to I2. In alkaline or neutral medium, I minus converted to IO3 minus. When acidified K2Cr2O7 solution is added, you know, K2Cr2O7, potassium dichromate, it is also a very strong oxidizing agent. It convert what is SN2 plus called stannous. Stannous becomes stannic. What is stannic? SN4 plus. Please note it all. What all conversions are done by K2Cr2O7. K2Cr2O7 convert iodide to iodine. Iodide to iodine, and sulfide S2 minus 2 sulfur, sulfide to sulfur, ferrous to ferric. Okay, ferrous to what? Ferric. And here what? Stannous mean SN2 plus, it becomes stannic SN4 plus, right? So conversion is important. What to what? Next. So here the question, stannous to what? Stannic. Next one, highest oxidation state of manganese in fluoride is +4. Mn for F4 mean Mn is in +4 stat, but highest oxidation state oxide is +7. You know what is the reason? We know higher oxidation state of transition metals are stabilized by only fluorides and oxide. Reason, fluorine and oxygen are most electronegative element, but compared to fluoride and oxide, oxides make more stability, or oxides form very higher oxidation state. Here you see fluoride form +4, but oxide can form +7. Why? Because when metal bonded with the fluorine only can form single bond with the metal. But when metal bonded with oxygen, they can form double bond with the oxygen. So who tried to take maximum electron from the metal? Oxygen. Okay, fluorine and oxygen both are highly electronegative element, but oxygen have an ability to form double bond with the metal, so they will take more electron from the metal, make it more oxidation state. So can you say what is the reason why fluoride shows less oxidation, oxide shows more oxidation state? We can say in covalent bond only while oxygen form double bond. Okay, so because we can say in covalent bond only while oxygen form double bond. Oxygen have an ability to form double bond, therefore it shows. Fluorine is more electronegative than oxygen. Yes, correct. But this is not reason for oxygen why it making more oxidation state mean oxygen can have ability to form double bond with the metal. Next one, although zirconium belongs to 4D transition series, already we discussed zirconium and hafnium. Zirconium is in 4D, hafnium is in 5D. Series why they have similar property due to lanthanide contraction, right? That's a consequence. Both have same number of electron, both have similar atomic radius, both belongs to same group of the periodic table. What is that? Both have similar atomic radii. Due to lanthanide contraction, 4D and 5D series elements have almost similar atomic radii. Therefore, zirconium, hafnium, similar properties. Why HCl not used to make the medium acidic in oxidation reaction of KMnO4 in acidic medium? Normally, when you do volumetry titration and all, KMnO4, if you want to acidify from the burette, when you add KMnO4, you will acidify it with what? H2SO4, right? We won't use HCl. Why? Dear, KMnO4 is a very strong oxidizing agent. So it will oxidize the HCl to what? Cl2. Okay, so KMnO4 is a strong oxidizing agent. It oxidizes the HCl to what? Chlorine gas. So KMnO4 oxidizes HCl into Cl2, which is also an oxidizing agent. So take care about that point. KMnO4, if you want to acidify, only H2SO4 we are using. HCl we won't use it because KMnO4 convert HCl to which one? Cl2. Next, what is a general, simple question, what is the general electronic configuration of transition metal? What is the general electronic configuration of transition metal? N-1D, 1 to 10, 1 to 10 and NS 1 to 2 or 2. Yes, where it is N-1D, 1 to 10, NS2, option A, right? Okay, yes. Next one. Which of the following pair of ions have same electronic configuration? Same electronic configuration if it having, what is that meaning? They have same number of electrons. They have same number of electrons, therefore they show same number of which one? Same electronic configuration, right? Okay, you just analyze later. Now I am going for the answer. Answer will be B. Let me just check it. Fe, what is atomic number here? 26, right? So what is the configuration? Argon. Okay, no need to write the configuration and all. Fe atomic number 26. So what do you mean by Fe? 3 plus 3 electron loss, right? So 23 electron will be there. All right. So Fe means 26. Okay, not that. Okay, let us just to go for that one. Ready. Copper, scandium. Okay, let's check it. So Fe is atomic number 26. So Fe 3 plus mean only 23 electron. What about Mn? Mn atomic number is 25. So Mn 2 plus means what? 2 electron loss. So that is also what? 23. So if they have same number of electron, their configuration will be same one. Right. Next. The second and third row element of transition, which is the second and third row, 3D, 4D, 5D. So second and the third row means which one? 4D and 5D. Okay. The second and third row element of transition metal resemble each other much more than. Already again we discussed what? Due to the lanthanide contraction. So lanthanide contraction which results in almost same radii of second and third. Yes, option A. Alright, so 3D is the first transition series, 4D and 5D are the second and third transition. Ready. 31. Reactivity of transition element decreases almost regularly from scandium to copper. Why scandium to copper? The reactivity of the metal decreases. Is it due to lanthanide contraction? No. Regular increase in atom ionization enthalpy. Regular increase, left to right, what happened here? Left to right, atomic size decreases. Atomic size decreases mean ionization enthalpy increases. What is mean by ionization enthalpy? Amount of energy required to remove an electron from the outermost shell. So smaller the size mean high nuclear charge, very difficult to remove electron. So left to right, ionization enthalpy, what happened? Increases, very difficult to remove electron. So the reactivity decreases. Now, copper plus ion, Cu plus ion is not stable in a aqueous solution because you may study this question like this one. Why copper in +1 state is unstable in aqueous solution, whereas copper 2+ is stable in aqueous solution? Yes or no? Why copper salt in +1 state is unstable in aqueous solution, but why copper 2+ is stable in aqueous solution? Reason you may study: copper 2+ having large negative hydration enthalpy. Copper 2+ having large negative. You know, when we can say that a oxidation state is stable, that depend on total energy. The total energy is the sum of ionization energy, hydration enthalpy, and enthalpy of atomization. Enthalpy of atomization. The sum of these three energies called the total energy. If the total energy is negative, stable the oxidation state. If the total energy is negative overall, stable the oxidation state. You see, copper 2+ having large negative hydration energy. So higher the hydration energy, if 2 negative in value, total energy will be negative, stable the oxidation state. So what is the answer? Second ionization enthalpy of copper is less than the first ionization. Large value of second ionization enthalpy of copper is compensated by much more negative hydration energy of which one? Copper 2+, right? Copper 2+. See, large value of second ionization enthalpy of copper is compensated by much more negative hydration energy of which one? Copper 2+. Therefore, copper 2+ is more stable, whereas copper +1 is unstable. Right. The first ionization energy of the element of first transition series titanium to copper. Just we discuss now, left to right means when you go across a period, atomic size decreases, ionization enthalpy increases. So we can say increases as the atomic number increases, first ionization. 34. The standard electrode potential of manganese 3+ to Mn2+ is high positive. A small hint, let me give you all. If they given you a metal manganese 3+ to manganese 2+, this value, what they said? High positive, right? High positive means there is a small hint, let me give you. If it is high positive in value, its 2+ state will be more stable. Okay, if the E0 value of a metal 3+ to metal 2+, if they given more positive in value, its +2 state basically will be more stable. So let me check it. Mn is the element, right? Mn is 25. So you know the configuration is what? Argon 4s2 3d5. So Mn2+, let me take it. What it will be? 3d5. Yes, it is stable. Okay, so when a metal, if they given you with a high positive in value with this 3+ to 2+, its +2 state basically stable. So what you can say, Mn2+ is d5 can be easily oxidized to Mn3+ d4 due to low ionization. No, the third ionization enthalpy of Mn is much larger due to stable half-filled. Third ionization enthalpy of Mn is much larger due to stable half-filled d5 configuration of Mn2+. Yes, Mn3+ more stable. No, option B. Option B. What is that point? Third ionization enthalpy of Mn is much larger. Yes, dear. See, Mn, what is Mn configuration? 3d5 4s2, right? So if you apply first ionization enthalpy, what happened? One electron goes. What it become? 3d5 4s1. If you apply second ionization enthalpy, one more electron go, it become 3d5. 3d5 means stable mean, yes, if it is stable, if you want to remove one more electron, you have to apply third ionization enthalpy. It will be greater because it's already stable. So third ionization enthalpy of manganese is much larger due to the half-filled d5 configuration of Mn2+. Yes, Mn2+ is what? d5. So overall, if they said the electrode potential is this is high positive, what you want to show that the +2 state will be highly stable. Ready? Now, Fe3 plus compound are more stable than Fe2 plus compound. Why? We studied Fe atomic number is 26. So configuration is what here? Argon 4s2 and 3d5. So Fe2 plus means what? This 2 will go. Sorry, this is 6, right? Yeah. Fe2 plus means what? 3d6. What do you mean by Fe3 plus? One more electron go from here. 3d5. Yes, it is half filled. So Fe3 plus compound are more stable. What you can say? Fe3 plus has 3d5 configuration. Yes. And copper sulfate is paramagnetic while zinc sulfate is diamagnetic. Why? Here copper sulfate, copper, what is the charge of copper 2 plus, right? Zinc sulfate, what is the charge of Zn? Zn 2 plus. Okay, let us check it all. Copper atomic number is 29. You know the exception in configuration, it is 4s1 3d10. But what do you mean by copper 2 plus? Copper 2 plus mean one from here, 3d9. What do you mean by 3d9? 3d9 you will fill 1, 2, 3, 4, 5, 6, 7, 8, 9. There is an unpaired electron. If the system having unpaired electron, they can show DD transition, become colored. But Zn case, you know, Zn in ground state and in Zn 2 plus state also, no unpaired electron. It is what? 3d10. So no unpaired electron means what? They cannot show DD transition. So it is colorless. So what you can say? Copper 2 plus ion has 3d9 configuration while Zn2 plus has 3d10 configuration. Yes. 3d5 no. Copper 2 plus has filled orbital no. Copper sulfate no. Right. Next one. Which of the following statement is not correct about magnetic property of metal? Diamagnetic substances are repelled by an applied. Yes, paramagnetic substances are attracted by the external magnetic field. Diamagnetic substances are repelled by the magnetic field. Paramagnetic substances are attracted by, yes. Magnetic moment, here it is wrong. What is the mistake in this question? You know, magnetic moment is root of n into n plus 2, not n minus 2. Careful. Next one. Most of the transition metals exhibit paramagnetic. Yes, dear, most of the transition metals having high unpaired electron, they are paramagnetic, not diamagnetic. They show variable oxidation state. Yes, they form color also. So 1, 3, 4. 1, 3, 4. Yes, these all are what? Correct. Next one. Transition metals makes the most efficient catalyst because already we discussed this one. Why transition metal shows variable oxidation? Why they shows different catalytic activity? Why they use as catalyst? Because of main two reasons. They shows variable oxidation state and they provide large surface area. So what is that? They adopt a multiple oxidation state. They show variable oxidation state. Form color, show paramagnetic for a large number of oxide. No. Reason for catalytic activity is what? It forms what? Variable oxidation state. Interstitial compounds are. Interstitial compound we discussed already. In the crystal metal, small gaps will be there. In the void, some small elements like oxygen, hydrogen, carbon are trapped. They're called the interstitial compound. Interstitial compounds are non-stoichiometric and neither ionic nor covalent. Interstitial compounds are non-stoichiometric and they are neither typically ionic nor covalent in nature. Not at all. Interstitial compounds are stoichiometric compound. They don't have stoichiometry, non-stoichiometric compound, and they're neither ionic nor covalent in nature. 41. Arrange the oxide of manganese according to increasing acidic strength. See, acidic strength if they ask. Acidic strength if they ask, calculate the oxidation state. Acidic strength is directly proportional to what? The oxidation state of the metal. In MnO, you know how to calculate the charge of Mn, right? In MnO, what is the charge of Mn, dear? In MnO, Mn is +2 charge. What about Mn3O4? Mn3O4 mean there will be 3 manganese, right? So 3x minus 8 equal to 0, x equal to what? 8 by 3, right? Next one, Mn to 8 by 3 is nearly what? The near value is enough. Okay, 2 point something will be there, right? Okay, 2 point something will be there. Now, what is Mn2O3? 2 manganese. So 2x minus 6 equal to 0, x equal to what? +3. And MnO2 mean manganese is +4. Mn2O7, 2x minus 14 equal to 0. So 2x equal to 14, x equal to what? 12. 6, right? Sorry, it will be 6. Sorry, 7, right? Sorry for that. So 2x equal to 14. So x equal to what? Plus 7. So greater the oxidation state, greater the acidic strength. So which one having greatest? So here plus 2, here more than 2, here 3, here 4, here 7. So same order, right? Option A is the correct. So where the metal shows higher oxidation state, where there will be higher charge, right? Higher acidic strength and oxidizing power. Okay, is that clear, that point? This is the same question. This is the same type of question they asked in 2024 board question, right? Okay. Next one is potassium dichromate. What is potassium dichromate? K2Cr2O7 is preparing from, potassium dichromate K2Cr2O7 is preparing from which ore, dear? Chromite ore. Chromite ore. What is chromite ore? FeCr2O4, right? Chromite ore. Whereas KMnO4, potassium permanganate, is preparing from where? Pyrolusite ore. What is pyrolusite? MnO2, pyrolusite. Do you remember the preparation? Very sure question for board exam. There are 3 steps in this preparation. There are 2 steps in this preparation. Can you say the 3 steps here? The chromite ore, first we treat with the sodium carbonate and oxygen, right? Chromite ore, we treat with the sodium carbonate and oxygen. It becomes what? Sodium chromate. Sodium chromate. Sodium chromate, second step, we treated with what? Acid, H2SO4. It becomes sodium dichromate. Sodium dichromate, when you treated with the KCl in third step, it becomes potassium dichromate. Please study the preparation. Potassium dichromate is preparing from chromite ore with the sodium carbonate and free access of air. 43. Which of the following compound is used as the starting material for the preparation of potassium dichromate? Just we discussed which one? Chromite ore, FeCr2O4. Okay, FeCr2O4. Yellow colored aqueous solution of sodium chromate changes to orange when acidified with the sulfuric acid because. Carefully listen that point all. Yellow colored aqueous solution of sodium chromate. What is sodium chromate? Na2CrO4. Na2CrO4. That just we discussed now. Sodium chromate is yellow in color. That means chromate is yellow in color. Okay, chromate is yellow in color. This chromate we will acidify in second step with the sulfuric acid. Sulfuric acid, it will, the Na2CrO4 become Na2Cr2O7, sodium dichromate. Sodium chromate on acidification becomes what? Sodium dichromate. And dichromate is what? Orange red in color. Orange red in color. So chromate on acidic medium becomes what? Dichromate, that is orange red. So what is the reason? H plus ion convert chromate ion to what? Dichromate ion, or formed during the reaction which impart orange color to the solution. No, which one? That H plus ion convert. It means H2SO4 is H plus, right? H plus ion convert chromate to which one? Dichromate. Chromate is yellow color, dichromate is orange red in color. Next one. What happens when potassium iodide react with the acidic solution of potassium dichromate? We discussed potassium dichromate convert iodide to what? Iodine. Iodide to what? Iodine. Iodide to what? Iodine. But that's not the, it will liberate iodine. Yes, correct. Potassium sulfate is formed. Chromium sulfate is formed. All of the above. Dear, very carefully to study the reaction. Potassium dichromate, when react with the acidic medium, it convert iodide to iodine. Yes, it is correct. Iodide to iodine. Yes, it is there. Along with that byproduct also you should study. Potassium sulfate form, chromium sulfate form, water also there. So what is that? All of the above products are formed. So all of these, such an option is there. It's our duty to cross check it. Okay, so all of the above. Now, acidified potassium dichromate, that means K2Cr2O7 in acidic medium, react with the potassium iodide and oxidizes to iodine. Yeah, potassium iodide Ki, which means I minus is there. I minus converted to I2, correct. What is the oxidation state of chromium in the product? Dear, carefully understand. If it is potassium dichromate, actually potassium not required here. Dichromate is the acting one, that is oxidizing agent. That means Cr2O7 2 minus. So in reactant side, how dichromate is there? Cr2O7 2 minus. When it is after oxidation, it becomes Cr3 plus. So they're asking in product side, what is chromium oxidation state? That is +3 oxidation stage. Remember all, in acidic medium, potassium dichromate or the dichromate converted to which state? +3 state. Ready? 47. Identify the correct structure of dichromate. Here it is compulsory to know the structure of chromate and dichromate. What is the structure of chromate? What is chromate? CrO4 2 minus, yellow in color, okay? Its structure is tetrahedral, double bond O, O minus, O minus. This is the structure of chromate. Here they are asking dichromate. What is dichromate? Cr2O7 2 minus, orange red in color. Its structure is Cr double bond O, O minus. Same one, another Cr double bond O, O minus. And in between there is a bridged oxygen. This is the structure of Cr2O7 2 minus. Can you check it? Where is this? Where is this? Cr double bond O minus, O Cr double bond O minus, right? Let's go with option A. Now, when MnO2 is fused with the KOH and O2, what is the product form? Here it is in the preparation of KMnO4. It is the question from preparation of KMnO4. 2 steps are there. Please study all. MnO2 is called pyrolusite ore. When pyrolusite ore, when react with the potassium hydroxide along with the oxygen supply, it becomes a dark green colored K2MnO4 called what? Potassium manganate. Potassium manganate. Okay. You know what is the second step? How you convert potassium manganate into potassium permanganate? This potassium manganate treat with acid, it become potassium permanganate, that is K2MnO4. Only 2 steps are there. Please study. So what is the dark green color? K2MnO4, that is the product in first step. Now, the equation MnO4 2 minus plus H plus. So, this is what? Permanganate, right? MnO4 2 minus, no. MnO4 2 minus, right? Not permanganate, that is MnO4 minus. So, MnO4 2 minus on acid, it become MnO4 minus. Okay, they are given a reaction. This reaction belongs to which type? Which type it is? Can you say? Mn, what is the oxidation state? Please find it all of you. Mn, take it as X. 1 oxygen minus 2, 4 oxygen minus 8, overall minus 2, so X equal to what? Plus 6, right? Here Mn is plus 6 state. What about product? Here Mn you calculate, it will be plus 7 and it is what? Plus 4. Plus 6 converted to plus 7. What is that? Increase in oxidation means that is what? Oxidation. And plus 6 converted to plus 4, decrease in number mean that is what? Reduction. Both oxidation and reduction happen to the same species. What do you call that? It is called disproportionation reaction. Question number 50 for you all. We are going for the 50 question. Which of the following is correct representation of acidified permanganate? Okay, acidified permanganate solution with a sulfurous acid. You know what is sulfurous acid? The ion present. It's also called a sulfite. That is SO3 2 minus. You should know first of all, KMnO4 as KMnO4, right? KMnO4 means how the ion is existing. We will write MnO4 minus. KMnO4, right? MnO4 minus. Permanganate, right? Yeah. Permanganate is what? MnO4 minus. Acidic medium, right? So what will be the H plus, right? Sulfurous acid is, they will written as SO3 2 minus. SO3 2 minus is called sulfurous acid or sulfite. And you should have an idea what all changes are going to happen for each thing. Carefully, very simple. During in acidic medium, MnO4 minus, that is our permanganate ion converted to Mn2 plus. Do you remember dichromate ion converted to what? Cr3 plus. Here MnO4 minus converted to Mn2 plus. And H plus becomes H2O. And sulfite becomes sulfate, SO4 2 minus. These are the overall changes. Check it where it is. MnO4 minus, SO3 2 minus, H plus, SO4 2 minus, Mn2 plus. Mn2 plus, not Mn plus. So, Mn2 plus, where is that? Okay, MnO4 minus, SO3 2 minus, not H2O. H2O should not be in this side. Only acid should be there. See, H2O is all mentioned in this side, right? No. So MnO4 minus plus SO3 2 minus plus H plus give SO4 2 minus N. Mn, this will be I think 2 plus. Okay, that's a mistake. 2 plus N 3H2O. Right. So basics are okay. MnO4 minus is there. SO3 2 minus is there. H plus is there. SO4 2 minus is there. Mn2 plus. Okay, mistake is there. So I'm correcting as Mn2 plus and H2O. Ready. And balancing or not checking out 2 Mn. Okay, 2 Mn. 5 sulfur. Yeah, 5 sulfur. 6 hydrogen. 3H2 means 6 hydrogen. Oxygen 2 into 4 8. 8 plus 15 23. Here 20. Yeah, 3 oxygen. Right. Option A. 51. The trend of basicity of lanthanoid hydroxide. You know, lanthanoids, we can say lanthanum to what? Lutetium, right? Lanthanum to lutetium. Lanthanum, basic charge of lanthanides, we discussed what? 3 plus. So lanthanum when combined with the hydroxide, you get lanthanum hydroxide LaOH thrice. Lutetium hydroxide is LuOH thrice. We know lanthanum to lutetium means across a period. Across a period, atomic size decreases. Across a period, atomic size decreases. Atomic size decreases means what happened here? Lutetium is smaller in size. So lutetium hydroxide bond will be very strong. Yes or no? Lanthanum to lutetium size decreases. So lutetium size is small mean lutetium with the OH group is very strong bond. Stronger the bond, it can't lose OH faster. Therefore, it bond least basic. Least basic. So, lanthanum to lutetium, what happened to the basic character decreases. You know, it's a consequence of lanthanide contraction. So, the trend of basicity of lanthanide decreases across the lanthanide series. Next one, what is the chemical composition of mish metal? One which is used in bullet and shell coating and all, right? Mish metal. Mish metal is, okay, it's actually an alloy. It is an alloy of 95% a lanthanoid element. Basically, we are using Cerium. 95% lanthanoid and 5% iron and traces of sulfur and all we are using. Where it is 95% of actinoid, no, 95% lanthanoid. 95% of lanthanoid metal with 5% iron and traces of sulfur, carbon, calcium, aluminum is called mish metal. What is the total number of inner transition element? What do you mean by inner transition element? Nothing but F block element. How many F block elements you have? You know, 14 elements are in lanthanoid, 14 elements are in actinoid, 14 plus 14, 28 elements are there in F block. What is the shape of d orbital? You know, d orbital dumbbell shape, right? D orbital dumbbell, which dumbbell? Double dumbbell shape, right? So p orbital, you know, s orbital spherical shape, p orbital dumbbell shape, d orbital double dumbbell shape, right? Double dumbbell in shape. Which of the following is diamagnetic? Already we discussed diamagnetic mean no unpaired electron. Where you don't have no unpaired electron, you cross check it one by one with the element. Let me go for mercury. Why mercury? Do you remember we studied zinc, cadmium and mercury. Zinc, cadmium and mercury are in the same group. They do not contain any unpaired electron. You know, Zn atomic number 30 configuration is 4s2 3d10. Cadmium is 5s2 4d10. Mercury is 6s2 5d10. So you see mercury is in 2 plus mean d10. D10 mean what? D orbital is fully filled. Zinc, cadmium, mercury, their ground state, even their oxidation state, their d orbital is what? Fully filled, no unpaired electron. So it is diamagnetic. Which of the following is not a part of the first transition series? Again, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, which is not belongs to this one. Again, that's what already we, I think that discussed. That's a magnesium is the one. Cobalt, chromium, nickel already there in 3D series. Transition metals show high enthalpy of atomization. Why? We said that transition metals contain high number of unpaired electron. If it having more number of unpaired electron, they form strong metallic bond. Their metallic bond will be very strong. If they have more number of unpaired electron, they form very strong metallic bond. Stronger the metallic bond, very harder to separate them. So that means they have high enthalpy of atomization. High Enthalpy of atomization, which means amount of energy required to break into their atom. Stronger the bond, high enthalpy of atomization. What is the transition metal show high enthalpy? They are variable oxidation, they know, colored no. More unpaired electrons are involved in metallic bonding. Yes. 58. Come on. What happened when ferrous ion react with an acidic potassium dichromate? What is potassium dichromate here? Cr2O7 minus. Acidic medium means what? H plus. Ferrous mean what? Fe2 plus. We studied dichromate ion. What it becomes? Cr3 plus. H plus what it become? H2O. Ferrous what it become? Ferric. Ferrous to ferric. So we can say the formation of what? Ferric ion. Next, acidified potassium permanganate. What is potassium permanganate? MnO4 minus. Acidified mean what? H plus. Combine with the potassium iodide. Potassium iodide contain iodide, right? Iodide and forms I2. Yes, it forms I2. I minus converted to I2, H plus converted to what? H2O, and MnO4 minus 1 converted to what? Mn2 plus. What is the manganese oxidation state in the reaction? Means oxidation state in the reaction in product. Okay, reaction in product. In product side, what is the oxidation state of manganese? Mn2 plus, right? 2 plus is the oxidation state. 60. In the dichromate anion, Cr2O7 minus. Its structure already we noted like this, right? Its structure is what? Cr double bond O, O minus, and OO, Cr, sorry. That's we have Cr double bond O, O minus. This is the structure of which one? Dichromate ion. Dear all, in dichromate ion, bond is very careful. Can you see this 6 bond? 1, 2, 3, 4, 5, 6. The outside terminal bond, their bond length is around 163 picometer. This all three means total 6 bond, their bond length is what? 163 picometer. Whereas the bridged one is around 179 picometer. The bridged one is 179 picometer. So in Cr2O7 minus dichromate ion, 6 CRO bonds are equal in length, which all 1, 2, 3, 4, 5, 6. So you may say, sir, this is double bond and single bond, right? How their bond length is same? Here, there is resonance is possible. In dichromate ion, resonance is there. So the double bond can be on any side. So all the CRO bonds, 6 CRO bonds are similar, but these two are different in length. So we can say all CR bonds are not the same. The 6 CRO bonds are same in length. Next one, which metal is used as an electroplated protective coating? Electroplating. Where we are using chromium is the metal we are using for electroplating. Next, filling the missing product in the following reaction. What is this? MnO4 minus permanganate. Which medium? Acidic medium. What is that? I minus. In acidic medium, I minus converted to what? I2. I minus converted to I2. But this is again permanganate. Water and iodine. Again iodine converted. But this is what? H2O, dear. Medium is, first one is acidic. Second one is neutral. In neutral and alkaline medium, iodide converted to what? Iodate. That is IO3 minus. Already we discussed that. So one is I2, second one is IO3 minus. 63, the total number of unpaired electrons in Mn3 plus. See, Mn atomic number is 25. So configuration is what? Argon with 4s2, 3d5. So what is the number of unpaired electron in Mn3 plus? 3 plus mean 2 from here, 1 from here, 3d4, right? So there will be 4 unpaired electron. Chromium, what is the atomic number? 24. You know the exception in the configuration, that is argon, 4s1, 3d5. But here chromium 3 plus, they are asking 1 from here, 2 from here, 3d3. So how many unpaired electron? 3 unpaired electron. What about last vanadium? Scandium, titanium, vanadium, 23. So 23 means what we can write? 4s2, 3d3. But vanadium 3 plus mean 2 from here, 1 from here, 3d2. How many unpaired electron? 2 unpaired electron. Ready? So question, what is the total number of unpaired electron and the most stable species. Check it. So unpaired electrons are what? 4, 3, 2, right? 4, 3, 2. 4, 3, 2. So D and B, we can cut it. 4, 3, 2. Which is more stable? You know, D4, D3, D2. Which is more stable? D3. Why D3 is more stable? You know, D3, which is more stable because when this orbital splitted, you know, 3 orbital goes to T2G, the 2 orbitals remain empty. You know, T2G at least is half filled, right? Since T2G orbital is half filled, D3 configuration is stable. So we can say 4, 3, 2 and Cr3 plus is the most stable one. Question 64. In alkaline solution, MnO4 minus changes to what? We already studied MnO4 minus, that is what? Permanganate ion. Permanganate ion. In acidic medium converted to Mn2 plus, okay? MnO4 minus is the permanganate ion which will converted to Mn2 plus in acidic medium. But here they are asking you in alkaline medium, in aqueous or alkaline, neutral or alkaline medium, you know, MnO4 minus converted to MnO2. Okay, MnO2, so answer is B. Remember all, in acidic medium, MnO4 permanganate converted to Mn2 plus, in alkaline medium converted to MnO2. Ready? Let's go for the next question. Which of the following is colorless ion out of the following? Colorless ion means they do not contain any unpaired electron. Where is no unpaired electron? Can you check it, all of you? Let me just, you can cross check it, right? So let me just take titanium. What is titanium? 22. 22 means what is the configuration? Argon with the 4s2 3d2. What do you mean by titanium 4 plus? All 4 electron gone. What is left? Argon. Argon means fully filled, no unpaired electron. No unpaired electron means what? It will be colorless. So titanium 4 plus. Which of the following statement concerning trans-uranium element is incorrect? What is trans-uranium element? The elements coming after uranium. Uranium atomic number 92. So after the element uranium, the elements are called trans-uranium element. They are highly radioactive elements. So their atomic number is greater than 92, correct? Example is thorium. No, thorium is not there. Thorium is 90. It is not belongs to trans-uranium. DK there show radioactive and elements after uranium. Yeah, the elements after uranium 92 above, they are called what? Trans-uranium elements. They are radioactive. Select the appropriate statement. Correct one. Both actinoids and lanthanoids are less basic. Both actinoids and lanthanoids are electropositive. Yes, they are metal. Both actinoid and lanthanoid do not exhibit magnetic and spectral property. No. Both actinoids and lanthanoid do not show same oxidation state of which one? +3. So the main thing, both actinoids and lanthanoids are what? They are electropositive. You may studying their similarity and dissimilarity between lanthanides and actinoids. So careful all. Both lanthanoids and actinoids shows what? They are metallic in nature, so they are electropositive in nature. Now, what happens to the atomic size of lanthanides as the atomic number increases? Atomic number always what? Left to right, what happened? Atomic size decreases, but due to lanthanide contraction, it is a steady but slow decrease in size. That's it. So the radius remain unchanged, or radius first increases, no. The radius what decreases. Whenever you go from left to right across a period, atomic size decreases. Which of the following is not a lanthanide property? They are soft metal with a white silvery color. They tarnish rapidly by air. The hardness of the metal increases with increase in, and the melting point of the metal range from 500 to 1000. No, it's more than 1000 here. It's already forgiven. Melting point of the lanthanide ranges from 1000 to 1200, not 500 to 1000. What is the lanthanide's first element? You know, lanthanides starting from where? Lanthanides final element they're asking. Lanthanides are starting from cerium to lutetium. Actinides are starting from thorium to which one? Lawrencium. Okay, what is the lanthanide final element? That is what? Lutetium. Lutetium is the final element. The property which is not characteristics of transition metal is, which is not a property of transition metal. They variable show yes, tendency to form color yes, formation of colored yes, natural radioactivity. No, transition elements are not radioactive, but lanthanide, actinide cases and all, there were more actinide and all, more radioactive elements are there. The pair of which both the elements generally shows only one oxidation state is, which will shows the pair shows only one oxidation state. That is our scandium and zinc. We studied scandium shows only one oxidation state +3, and what is the oxidation state of zinc? Always +2. Scandium and zinc shows only one oxidation state. Which of the following characteristics of the transition metal is associated with a higher catalytic activity? Again, variable oxidation state, high catalytic activity because of two reasons, because of variable oxidation state and which one, they provide large surface area. So variable oxidation state. Now in KMnO4, what is the oxidation state of Mn? Simple question. Potassium, what is the oxidation state? 1. Manganese, we don't know. 1 oxygen -2, 4 oxygen -8, overall 0, X equal to what? +7. In KMnO4, manganese is in +7. Transition elements show variable oxidation state due to the loss of electron from which of the following orbitals? Transition elements show variable oxidation state because its n-1d orbital and ns orbital have almost similar energy, so those electrons can take part in bonding. So from where they lose electron? From ns and n-1d, n-1d and ns. 76. The structure of manganate and permanganate are. What is the structure of manganate? Manganate is MnO4 2-. Permanganate is MnO4-. Ready? So MnO4 2 both having tetrahedral structure. Tetrahedral structure. This is manganate, and permanganate will be Mn double bondo, double bondo, double bondo, O-. Both having tetrahedral structure. Tetrahedral. Even chromate and dichromate also tetrahedral. What is the oxidation state exhibited by actinium? Actinium. What is the oxidation state exhibited by actinium? Actinium, the elements, actinoids and all, the general oxidation state is which one we discussed? +3. Common oxidation state, okay, actinium. So just to check it all of you, actinium atomic number is 89. How we write 89? We can write it as the configuration, we can take it radon. Radon atomic number is 86. Okay. After that we have 5f, 6d and 7s orbital. So after 86, 3 more electrons are there, 2 here, 1 here. See, whenever they lose these 3 electrons, they get noble gas configuration. So +3 is their state. Where does the last electron of d block elements go? D block, if it want to be d block element, the last electron should go to d orbital, which is that n-1d orbital, because what is the general electronic configuration of d block element? n-1d, 1 to 10, right? 1 to 10 and ns 1 to 2 or 2. So where the last electron is entering after filling s, electron comes to n-1d. 79. What is the common oxidation state of scandium? Just we discussed the scandium common oxidation state is 3+, because you know the reason, scandium atomic number is 21. So configuration will be argon 4s2 and 3d1. So scandium 3+ mean what? It will lose this 3 electron. So argon is stable. So scandium shows +3 oxidation state. Identify the incorrect statement. So that's the question, right? What is the common oxidation state? Yeah. What identify the incorrect statement among the following? D block elements show irregular and erratic chemical properties among themselves. Lanthanum and lutetium have partially filled d orbitals only. The chemistry of various lanthanides are very similar. 4f and 5f orbitals are equally shielded. What is the answer? D. 4f and 5f, dear. 4f is lanthanoid, 5f is actinoid. You know, actinoid contraction is more than lanthanide contraction because due to the very poor shielding effect of which one? 5f. They said 4f and 5f having same, no? 5f having very poor shielding effect than 4f. Therefore, actinoid contraction is more than lanthanoid. The elements which contain incompletely filled d orbital either in ground state or in their oxidation state, what you call? transition element. If it want to be a transition element, the element should contain incompletely filled d orbital either in their ground state or in their oxidation state. Silver, Ag, silver atomic number 47, its configuration, krypton is atomic number 36. Remaining we have 5s1 and 4d10. This is the configuration of silver, okay? Silver atomic number 47 is the configuration. Silver actually contain completely filled d orbital in their ground state, but it is considered as a transition element. Here, if it want to be a transition element, what is the condition we said? Either in ground state or in excited state, oxidation state, they should have a incompletely filled d orbital. This is ground state. Let me check the excited. Silver shows two oxidation state, +1 and +2. Let me take +2. +2 state mean one from here, one from here. What is left? 4d9. See, the d orbital is incompletely filled in its oxidation state. Therefore, it is a transition. So, this having a incompletely filled d orbital in its +2 state. Question 83. Which of the following element shows less melting point in 3D series? We know scandium, titanium, vanadium, chromium, manganese. You know this graph, you may study it in class also. In this compound here, you may have seen that you can able to see this. This is the 3D series. Okay, please observe this graph. This is the melting point increasing. Atomic number is increased. This is titanium, vanadium, chromium, manganese. Which one having low melting point mentioned? Manganese. Why? When an element show high melting point, first of all, if more number of unpaired electrons are taking place in the reaction, in the bonding, they form strong metallic bond, so their melting point will be high. Manganese, manganese, the configuration is what? 4s2 3d5. It is a stable one. It's half-filled stable, right? Since manganese is having a stabilization, the all electron cannot take part in bonding. So, less number of unpaired electrons only can take part in bonding. Therefore, it form weak metallic bond. Weak metallic bond means less melting point. Okay. So, among which of the following element shows less melting point among this element is manganese. Reason if they ask, manganese having half-filled stabilization, stable the compound, all unpaired electron cannot take part in bonding. So, they form weak metallic bond. So, their melting point is lesser. Next one, which transition element in the following shows only one oxidation state? Already we discussed the scandium shows only one oxidation state, +3. Which transition element in 3D shows highest oxidation state? What is our 3D series? That is our scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Here, which will shows the highest oxidation state? Middle element. What is the middle element? Manganese. It shows +7. In 3D series, highest oxidation state is given by manganese +7. 86. The highest oxidation state in transition metal compound are achieved in fluorides and oxide. Yes, we studied. Why the higher oxidation state only possible with oxides and fluoride? Because oxide and fluorine are most electronegative element. They make very strong ionic bond. So high electronegativity of fluorine and oxygen, yes, they form weak and no. They form very strong bonding. Okay, more number of unpaired electron variable. No, due to the high electronegativity of fluorine and oxygen, they will try to pull maximum electron from the metal. So metal can show higher oxidation state. Magnetic moment of scandium 3+. What is the equation for magnetic moment? Root of n into n plus 2 Bohr magneton. Scandium, right? Scandium is 21. 21 means what? Argon 18. 4s2 3d1. Scandium 3+ mean this 2, this 1 gone. Only 18. 18 means what? Fully filled. No unpaired electron. No unpaired electron means what? Magnetic moment is 0. Why transition element form complexes? There are mainly 3 reasons why transition element form coordination complexes. Because the metal are smaller in size. Because of smaller in size, they have high charge density. And third one, they provide, they have vacant d orbital. So they comparatively smaller in size. Yes, they have high ionic charge. Because of small size, they have high ionic charge and availability of vacant d orbital. All of these, okay, all of these. What are the properties of interstitial compound? We studied 4 property. Higher melting point than pure metal? Yes. Very hard? Yes. They retain their metallic conductivity. Yes. One more is that actually they are chemically inert. So all of these are property. 90th question. In acidic medium, yellow chromate. What is chromate dear? CrO4 2 minus, right? CrO4 chromate, CrO4 minus ion is converted into which one? See, acidic, they are asking acidic medium. We already discussed the chromate become dichromate. Chromate is yellow color, right? Chromate is yellow color. Yes, chromate is yellow in color. And when it is converted to CrO4 2 minus, chromate, when it is in acidic medium, it converted to what? Dichromate, right? Chromate is what? Yellow in color. Sorry. Chromate is what? Yellow in color. This is what? Chromate. Chromate, Cr2, CrO4 2 minus. And dichromate is what? Cr2O7 2 minus. Chromate is yellow in color. In acidic medium, it converted to dichromate. That is what? Orange red in color. Orange red. 91. KMNO4 is preparing from. KMNO4 is preparing from which oral? Manganese dioxide. MnO2, that's called pyrolusite. Pyrolusite ore. Chromite ore is which one dear? FeCr2O4. It's a FeCr2O4. It's a preparation of which one? A dichromate ion. Potassium dichromate. Pyrolusite ore is which one? MnO2 from where we are preparing KMNO4. What is galena? That is an ore of lead, okay, PbS. And the bauxite, you know, aluminium ore, Al2O3. So pyrolusite ore. 92. When KMNO4 heated, what form? Here there is an equation. KMNO4, when you heat it, it becomes three things. K2MnO4, MnO2 along with the oxygen. So KMNO4, when you heat it, it will give you potassium manganate. What is KMNO4? Potassium permanganate. What is K2MnO4? Potassium manganate. Potassium manganate. Ready? So what happened? KMNO4 heated, it forms what? K2MnO4. How many Mn double bond O bonds are in permanganate? We already discussed the structure of permanganate. What is permanganate? Permanganate is MnO4 minus, right? So we can draw like a double bond O, double bond O, double bond O, O minus. A small hint is there. MnO4 minus, right? Minus 1, right? Minus 1. Minus 1 means there is only one oxygen with a minus 1 charge. There is only one oxygen with a minus 1 charge and single bond. Remaining all the three oxygen will be double bond. What is that? Overall charge is minus 1 mean there will be only one oxygen with a charge minus 1 and it is single bonded oxygen. Rest of all oxygen double bond. So how many Mn double bond O bonds are there? 1, 2, 3. 3 are there. Next. In acidic medium, KMNO4 convert nitrite. NO2 minus is called what? Nitrite converted to what? Nitrate. What is nitrate? NO3 minus. Please note KMNO4 convert which all compound to which one? One is iodide in acidic medium. Okay, I'm saying in acidic medium, I minus converted to I2. Ferrous converted to what? Ferric. Sulfide converted to what? Sulfur. Sulfite converted to what? Sulfate. And oxalate C2O4 2 minus converted to carbon dioxide. And nitrite NO3 minus converted NO2 minus converted to NO3 minus. Nitrite converted to nitrate. Which of the following is the consequence of lanthanide? There are three consequences we studied in lanthanide contraction. One is the 4D and 5D transition element series shows similar atomic size. Second one, separation of lanthanide from mixture is very difficult. We can predict the basicity from lanthanum to lutetium, basicity decreases. Element of 4D and 5D series have similar size, yes. Separation of lanthanide element from its mixture is very difficult because they have similar size. Can predict the basic nature. See, lanthanum to lutetium to lanthanum, or we said lanthanum to lutetium, it decreases, right? Yes, correct. So all of these are the three consequences of lanthanide contraction. 96. Name a member of the lanthanoid series which is well known to exhibit +4 oxidation state. Here in lanthanide, +4 state is mainly given by cerium. Simple. Cerium atomic number 58. Why? Because lanthanum atomic number is 57. After lanthanum, lanthanides are starting, right? First lanthanide is cerium. Cerium configuration, let me write. Xenon 54, then we have 4f, 5d, 6s. After 54 to 58, 4 more electron, we can fill 2, 1, 1. If they remove all these 4 electron, they are getting stable configuration. So cerium common oxidation state is what? +4. Now, lanthanides react with the oxygen and form. There is a chart given in your textbook. Lanthanum, they mention as lanthanum as the generalization Ln. You know, lanthanum general oxidation state is what? 3+. Oxygen general oxidation state is what? -2. So what is the formula of lanthanum oxide? Ln2O3. That's it. Ln2O3. Then actinide contraction is more. We studied actinide contraction is more than lanthanide contraction because of the very poor shielding effect of 5f orbital. Actinide contraction is more than lanthanide contraction due to the poor shielding effect of 5f orbital in actinoid. Okay, 99, second last question. In dichromate ion, what is the dichromate ion structure? You remember? Cr double bond O minus. Cr double bond O minus, and there is an oxygen. So in dichromate ion, how many CrOCr? There is only one, right? How many CrOCr bond is present? One. Basically, they're asking whether you know the structure or not. Ready? Last question, number 100. In the preparation of K2Cr2O7, how many steps are there in preparation of K2Cr2O7? 3 steps are there. Once again, I am reminding you, K2Cr2O7 is preparing from which ore? Which ore we are preparing here? We are preparing from pyrolusite, sorry, the chromite ore, right? What is chromite ore? FeCr2O4. First chromite ore we will treat with the sodium carbonate with the free supply of oxygen. So the FeCr2O4 become Na2CrO4. That's called a sodium chromate. Byproduct and all we have to study, okay? Second step, this is the first step. In second step, you know what happened? Sodium chromate, we will react with the acid, which is the acid we are using, H2SO4. Sodium chromate become Na2Cr2O7, sodium dichromate. The sodium dichromate in third step, we will treat with the KCl. So potassium comes, you will get K2Cr2O7. Sodium dichromate become potassium dichromate. So question, in the preparation of K2Cr2O7, chromite ore means this one, converted to sodium chromate. Sodium chromate is this one. By which reaction? By treating with what? Na2CO3 and oxygen. That is option A. Hi guys, coordination compound, most important 100 MCQs. Let's discuss in this session. You know, coordination compound is an entirely different chapter compared to the other concepts. The IUPAC nomenclature of coordination compound, their types of ligand, how to calculate the oxidation state of the metal, and how to calculate the coordination number. That different theories are there, you know, Werner's theory, valence bond theory, crystal field theory, application of coordination compound, why they show color, what is the stability order, spectrochemical series, lot of concepts, isomerism, right? Many concepts are there from the chapter coordination compound. So let us discuss about the 100 most important question from the chapter coordination compound. I hope we can cover the entire theory also. Ready? Question number 1. Which of the following is the coordination entity in this one? You know what is meant by coordination entity is also called a coordination sphere, the bracket. The square bracket, you know, the square bracket contains central metal atom and ligand. That part is called what? Coordination entity or coordination sphere. And the one which is present outside the bracket, you know, that is called it as counter ion, right? Counter ion. So here this is the coordination entity or coordination sphere. Yes, D is the answer, right? You know, in a coordination sphere or in coordination entity, we have the central metal atom first, then we have ligands. Correct. Second question, the central metal atom of a coordination complex is also referred to as. For example, let me consider FeCN6 4-. Here, which is the central metal atom? Iron, right? This is considered as what? Whether it is a Lewis acid, Lewis base, Bronsted, like that. You may study the Lewis concept and Bronsted concept in 11th grade. What is a Lewis acid? Lewis acid is a electron pair acceptor. Electron pair acceptor. What is a Lewis base? Lewis base mean electron pair donor. Electron pair donor. And what is meant by Bronsted acid and Bronsted base? You know, proton donors are acid, proton acceptors are bases. Here proton concept is not in our coordination compound. They are electron transfer is electron pair donor and electron pair acceptor is there. You know, ligands. Ligands are electron rich. They are donating electron. So the ligands are Lewis bases. Generally Lewis bases are which one? Ligands. And the central metal atom, they will accept the pair of electron. Therefore, the central metal atom belongs to which one? Lewis acid. So generally ligands give electron, therefore they are Lewis bases, and metals gain electron here, therefore they are Lewis acids. Okay. Next one, identify the Lewis acid in this complex. Lewis acid means what? The central metal atom. Which is the central metal atom here? Aluminium. Whether it is aluminium or aluminium 3+, my dear, check it. What is the charge of aluminium in this case? You know, potassium charge is +1. So 3 potassium plus 3, aluminium X. And you know, this is oxalate. Oxalate charge is -2. So 3 oxalate is -6. Overall 0, X is equal to +3. Yes, here aluminium is in what charge? +3 charge. So that is the Lewis acid in this one, or the central metal atom in this complex. Next one, which of the following is the central atom ion in this complex? Which is the central atom here? Cobalt. But what is the oxidation state that we have to know? We don't know what is cobalt oxidation state. Like, let us take it as X. You know, chlorine charge is -1. Amine is a neutral ligand. Overall charge is +2. So we will get X is equal to +3. Yes, cobalt in 3+ state in this one. You know how to, I hope you all, my dear student, you know how to calculate the oxidation state of the metal. You know what is the charges of each and every ligand, correct? Next one, which of the following cannot be a ligand? Which of the following cannot act as a ligand? You know, ligands are either negatively or neutral charged species, right? Ligands are negatively or neutral charged species. Of course, which one? Nickel 2+, right? Nickel 2+ is a metal. It's having positive charge. Ligands are negatively or neutral charged species, right? Yes, you know, this is negative charge. This is neutral charge. See, because of the lone pair, they're electron donating one. Now, how many donor atoms can EDTA 4- ligand bind through? You know what is EDTA full form? My dear, EDTA is what? Ethylene diamine tetra. Tetra means 4. What? Acetate. CH2COO minus, CH2COO minus, CH2COO minus, CH2COO minus. This is the compound called EDTA, ethylene diamine tetraacetate. We studied in classes, if there is a metal atom present, how many donor atoms are present in a EDTA? You know, negatively charged positions are donor atom because they are electron rich. Negative indicate that electron rich. It is 4 donor atoms are there, but not 4 is the answer. 6 is the answer because nitrogen contain lone pair, my dear. That is also donor atom. So one EDTA can donate 6. That is 6 donor atoms are present. So answer is 6 and 6. And EDTA is considered as a hexadentate ligand because there are 6 donor atoms. So EDTA we studied under polydentate ligand. EDTA having 6 donor atom. Therefore, it is considered as a hexadentate ligand. Answer is 6. What is the coordination number of the chromium in this one? What do you mean by coordination number? You know, coordination number mean it is the number of sigma bond around the central metal atom. See here the central metal atom is chromium, right? It is surrounded by C2O4. What is C2O4? Oxalate. You know, oxalate, how many are there? 3 oxalate are there. You know very well, oxalate is a bidentate ligand. So, 1 OX provide 2 sigma bond. So, total 3 OX will provide 6 sigma bond, my dear. So, what is the number of sigma bond? 1, 2, 3, 4, 5, 6. So, 6 is the coordination number. What do you mean by coordination number? It is a total number of sigma bond around the central metal atom which is created by the ligand. OX, C2O4 is OX. That is oxalato. Oxalato is a bidentate ligand. So 1 OX provide 2 sigma bond. So this is the maximum sigma bond. Identify the coordination sphere in the compound. What is coordination sphere? This one. Coordination sphere means the square bracket. It's also called coordination entity, my dear. Option C is the correct answer. Here K4. What is K? Potassium that is outside the bracket. That is called the counter ion. Okay. So counter ion, and this is the coordination sphere. Next one. What is the sum of? What is the sum of the metal coordination number? Sum of coordination number and oxidation number of this metal. See, this is the metal. Let us calculate the oxidation state. Let me calculate first. Metal X, En, charge is 0, neutral ligand. C2O4, one oxalate charge is -2. Yes, overall 0. So X is equal to +2. So 2 is the oxidation state. Let us calculate the coordination number. Metal is there. En twice. En is a bidentate ligand. So 1 En provide 2 sigma bond. So 2 En provide 4 sigma bond. And C2O4 is our oxalate. That's also a bidentate ligand. Total 6 coordination number. So oxidation state 2, coordination number 6. Overall, what is the sum? We can write 8 is the total sum. Okay. So they're asking you what is the sum of the coordination number and oxidation number. Coordination number is 6 here and oxidation state is what? 2 here. Okay, dear all. Next one, when silver nitrate in excess is treated with the complexes COCl3 6NH3, COCl3 5NH3, COCl3 4NH3, their molecular formula is given. The right order of the stoichiometries of AgCl produced is this respectively. Let me take this complex first. Cobalt is the metal atom. See, 6 amine is there, right? 6 amine and 3 chlorine is there. You studied a spectrochemical series where amine and chlorine, when you consider which is the most strongest ligand, amine is strongest ligand. Always amine, the strong ligand form the bond initially first. Okay. So strong ligand you add first. So what is a strong ligand? Amine. How many times are the NH3? 6 times. And close the bracket and the remaining 3 chlorine outside. Keep in mind, maximum you can place 6 ligand inside. Maximum coordination number possibly 6, okay? Remaining all put it outside. So this is the first complex possible. What about the second complex, dear all? The second complex is COCl3 5NH3. It's only have 5NH3. So let me place 5NH3 first. Then 1 chlorine I can put it inside because maximum you can place 6 inside. So 5 plus 1, 6. Remaining 2 chlorine outside, okay? What about the last one? Only 4NH3. So CONH3 4 times, Cl2, this time I can place 2 chlorine inside because 4 plus 2 total 6 you can place inside and 1 chlorine outside. And this compound they are treating with the what? They are treating with the silver nitrate, right? They are treating with the silver nitrate. If you treat it with the silver nitrate, this AgCl combined, you will get AgCl. So here 3 chlorine outside, all counter ion can undergo reaction. So here 3 chlorine outside, it will give you, first one give you 3 AgCl. Second one 2 chlorine outside, so it will give you 2 AgCl. Last one only 1 chlorine outside, so it will give only 1 AgCl. So you will get 3 to 1 AgCl from these compounds. So what all things we have to be careful to answer this question, my dear? Inside the sphere, maximum you can place 6 ligand, which means 6 coordination number. Remaining all you should keep it outside. And the strong ligand always you should put it inside. Okay, strong ligand always bond first. Then how many chlorines are outside? A same amount of AgCl you will get it. Here 3 chlorine outside, therefore 3 AgCl. 2 chlorine outside, 2 AgCl. 1 chlorine only outside, 1 AgCl. Like that. 1 AgCl, okay? AgCl. That's not AgCl to AgCl. Next question. Isomerism in the FAC and MER. Okay, we studied FAC and MER isomer. And along with the meridian will be demonstrated. We studied that FAC and MER isomerism is given by the complex octahedral complex, my dear. Octahedral complex is giving you the FAC and MER isomer with the type MA3B3 type. MA3B3 type. The type MA3B3 shows FAC and facial and meridian isomerism. Which is that type? I think it is option A, MA3B3 type. That's it. And this you think this is MA4B2. This is MA6, right? MA6 means because En is a bidentate ligand. So 3En means it will be 6 site, okay? And this is MA5B. No. FAC and MER isomer is only given by the type MA3B3. That is option A. Which of the following has the highest molar conductivity? Keep in mind all of you, the one which is giving you more ion, their molar conductivity increases. The one which is giving more number of ions, it can conduct more electricity. So let me take you how to write their ions. Dear all, this complex is only the coordination sphere. Coordination sphere do not dissociate, do not break, that won't give you any ions. So no ions here. What about this one? This complex breakdown as CONH3 4Cl2 plus and Cl minus. See this compound you please treat it as NaCl. NaCl, how it break? Na plus and Cl minus. Same way, this complex plus and Cl minus. Okay. And what about K4FeCN6? It break as how many potassium outside? 4 potassium outside. So it will give you 4K plus and FeCN6 4 minus. So total 4 plus 1, you will get how many? 5 ions you can get it. How many ions here? 1 plus 1, only 2 ions. What about this compound? What about this compound? You consider as this is what? AlCl3. How you break AlCl3? Al3 plus and 3Cl minus. Same way, this is Al, this is Cl3. We will get CrH2O thrice 3 plus and 3Cl minus. Total how many? 1 plus 3, total 4 ions. The one which is giving more number of ions can conduct more electricity. So option C is the one giving 5 ions. So that's having more conductivity. Okay, clear all? Molar conductivity. So the one which is giving more ion can conduct more electricity. Next one. Atomic number of chromium, manganese, iron, cobalt and all given here. Which of the pair with the same magnetic moment? Magnetic moment is calculated by the equation root of n into n plus 2. The unit you know, Bohr magneton. Magnetic moment nu is equal to root of n into n plus 2. You know what is that n? N is the number of unpaired electron. So where number of unpaired electrons are same, where magnetic moment also same. So you want to calculate the, let me check it, option A, okay. Which is the central atom? Chromium. Chromium, you know, atomic number 24. Normal configuration, right, like argon 4s2 3d4. You know, our chromium, there is an exception case. Anyway, you are going to lose electrons, so no need to make. Chromium here, charge is which one? 2 plus. So chromium 2 plus mean this 2 electron gone. What is remaining? 3d4 is remaining, right? 3d4 is remaining. After getting 3d4, you know, chromium is the H2O is a weak ligand. So pairing won't happen. So the 4 electron exists as what? 1, 2, 3, 4. 4 is the unpaired electron. But what about this case? This pair is given as cobalt. You know, cobalt atomic number is 27. Configuration is argon with 4s2 3d7. Here cobalt charge is also, when you calculate, you will get 2 plus. So this gone. So what is remaining? 3d7. Water, chlorine, you know, halogens are weak ligand. Electrons won't undergo pairing. So 7 electron, how it is existing? 1, 2, 3, 4, 5, 6, 7. Here only 3 unpaired electron. Here 4 electron, here 3 electron. Definitely their magnetic moment won't be same because their number of unpaired electrons are different. So let me check it with the option B. Option B, I think the first case is similar. Okay, here n is equal to what? 4. Let me check the second one. You know, Fe atomic number is 26. So configuration is what? Argon 4s2 3d6. And Fe charge is also here 2 plus. So this 2 gone. 3d6 is there. 3d6 mean how you write the electron, my dear? 1, 2, 3, 4. Yes. In these two cases, number of unpaired electrons are same. Number of unpaired electrons are same mean their magnetic moment also same. I think option B is the correct answer. So where magnetic moment is same means they having same number of unpaired electron. Which one having higher magnetic moment if they asking you where number of unpaired electrons are higher in number. Next one, what is the correct order of the field strength? You know, the spectrochemical series, weak ligand to strong ligand, the arrangement you may study. Which is the correct order of their spectrochemical series? Many times this is a repeated question, my dear. Tell me which is the correct order of the ligand. You know, carbonyl is the strongest ligand, then cyanide, then ethane 1,2-diamine, then amine. Option A is the correct answer. Please study, all of you, the spectrochemical series. Then the chelate effect is the stabilization, right? You know, chelating ligands are there in the complex. Yes, what is chelating ligand? They are bidentate or polydentate ligand. If there is chelating ligand in your complex, yes, we studied that, they can form which one? Stability. And which of the following complex species is the most stable due to chelation? Which is a chelating ligand? Option C, dear all, oxalate is there. What are the bidentate ligand we studied? Oxalate and EN, right? So in order to form chelation, what is required? Bidentate or polydentate ligands are required. You know, these all are what? Monodentate ligands. Then coordination compound exhibit isomerism due to the presence of ambidentate ligand. Which one? Linkage isomerism, right? Linkage isomerism. If the coordination complexes contain the, which one? The ambidentate ligand, they can show linkage isomerism. See, all of you, palladium C6H5 SCN, you know, SCN is an ambidentate ligand, thiocyanate. Its pair is which one? NCS. Their connection is different, right? Here palladium connected to sulfur, here palladium connected to nitrogen. That is called what? Linkage isomerism. Then what is the IUPAC name of the complex? You can able to see amine is there, bromido is there, nitrito, N is there, chlorido is there. Alphabetical order, what we can write? Amine, right? 3 amine are there. Therefore, triamine, then bromido, yes, then bromido. Then chlorine is there, chlorido. What is NO2? Nitrito N. Who is the metal? Platinum is the metal, platinum. What is the oxidation state of platinum, my dear? Platinum, take it X, amine 0, 1 bromine -1, NO2 -1, chlorine -1, even outside 1 chlorine is there -1, overall 0. You will get X is equal to what? +4. Yes, we are getting 4, and outside counter ion, don't forget to write chloride, right? Chloride, which is the most suitable answer. Check it all. Triamine, you know, chlorido or chloro we can apply, okay? Similarly, bromido, bromo. So triamine, bromido. So this is not correct. Triamine, bromido, chlorido, nitro. Nitrito N, or sometimes they used as what? Nitro. Platinum for chloride. Yes, option C is the most one. As per the rule, it is correct. Now, what is the primary and secondary valency of platinum in this one? You know, according to Werner's theory, primary valency gives the oxidation state. Primary valency gives the oxidation state. Secondary valency give you the coordination number. So, calculate the oxidation state and coordination number. Here, platinum oxidation state X, En is a neutral ligand, 2 chlorine -2, overall 0, X is equal to +2. So 2 something, that is option D, correct. And what is the secondary valency? Here platinum is the metal, En is a bidentate ligand. So 2 En give you 4 bond and 2 chlorine are there. Total how many sigma bond? 6 sigma bond. So 2 and 6 is the primary valency and secondary valency. I mean, and you studied that primary valency is also called ionizable valency. Secondary valency is also called non-ionizable valency. That's also be careful. Which of the following has magnesium? Magnesium. We studied in our application part, in biological system, coordination compounds are present. For example, hemoglobin, iron is the central metal atom. Chlorophyll pigment, magnesium is the central metal atom. Vitamin B12, cobalt is the metal atom. So where is magnesium present? That is in chlorophyll, my dear. Hemoglobin, what is the central atom? Iron. And vitamin B12, cobalt, like that we studied in our application part. Then a chelating agent has 2 or more than 2 donor atom to bind to a single metal ion. Yes, they are bidentate or polydentate. Which of the following is not a chelating agent? Not a chelating agent. You know, thiosulfato. Thiosulfato, let me write it as, mostly they give you Thiocyanate. Okay, mostly they give you what? Thiocyanate. What is thiocyanate? SCN. Then what is oxalato? You know, C2O4 2 minus. What is glycinato? You will study in biomolecule chapter glycine, where glycinato is what? NH2CH2COO minus. And ethane 1,2-diamine, that is our EN, right? Ethane 1,2-diamine is our EN ligand. Question. Which of the following not a chelating ligand? You know, thiocyanate is a what? It is a ambidentate or monodentate ligand. It cannot form two bonds at a time. Whereas oxalate is a bidentate ligand, EN is a bidentate ligand. Here you see this nitrogen and this oxygen. Yes, two donor atoms are there. So SCN, thiocyanate is which one? A monodentate or ambidentate ligand. So they form only single bond. So cannot form ring, right? What is the IUPAC name of the complex? Dear all, amine is there, chlorine is there, nitrito N is there. Two amine, right? There are two amine. So let us start all of you. Diamine, right? Diamine, chlorido, and what is NO2? Nitrito N. Then which is the central metal atom? Platinum. There is no counter ion, write the oxidation state. Platinum oxidation state X, amine is 0, chlorine is -1, and NO2 charge also -1, overall 0, X equal to +2. What is the answer, my dear? Diamine, chlorido or chloro, nitrito and platinum 2. Yes, option 3 is the correct answer. Please cross check it, all of you. Okay. In the complex, you can able to see there is a complex given. EN is ethylene diamine, okay. Dash are the coordination number and the oxidation state. They're asking you coordination number first, oxidation state second. What is the coordination number? E is the metal, En are 2 time. You know, 1 En provide 2 sigma bond. So 2 En provide 4 sigma bond. And oxalate is also there. Oxalate is also bidentate. Total 6 sigma bonds are there. So starting 6. Then what is the oxidation state? E charge is X. En is neutral ligand. Oxalate is -2. Nitro is -1. Overall 0. X is equal to +3. So 6 and 3. Where you can see, my dear, option 4, 6 and 3. See how many questions are repeated. They ask you the oxidation state and coordination number. Okay, careful. The type of isomerism shown by the complex is, what is this complex? First of all, you have to judge it. What complex is this? This is octahedral. How you can judge it octahedral? Coordination number should be 6. Then it will be octahedral. See here, cobalt is there, right? Cobalt. Cobalt connected to 2 chlorine. Yes, 2 chlorine. And En is there. En means what? 2 En mean it will provide total 6 are there. 6 is the coordination number. That means it is octahedral. You know, octahedral, what is this type? This type is Ma2B4. Ma2B4. Why B4? Ma2, you know, En is a bidentate ligand. So 1 En provide 2 side. So 2 En provide 4 site. Therefore B4. Ma2B4 octahedral complex shows cis trans isomerism or the geometrical isomerism, my dears. If it is octahedral, if it is a type of Ma2B4 or Ma4B2, then it will show cis and trans isomerism. That is also called what? Geometrical isomerism. Keep in mind. Hemoglobin is a complex compound of which metal ion? We discussed that hemoglobin contains ferrous ion. Ferrous. Which one? Fe2 plus. The complex ion, you can able to see 2 complex here. What type isomerism is this? Very simple. A nitrito N is there, nitrito O is there. If there is a chelating ligand, yes, it will show which isomerism? Linkage isomerism. So that points are, I hope it is clear. 6. What is more salt? We studied more salt is a double salt, right? More salt is a double salt. More salt contain ferrous sulfate. Double salt in the sense it's a combination of 2 salt. More salt contain ferrous sulfate. What is ferrous sulfate? FeSO4 and ammonium sulfate NH4 twice SO4 along with the 6H2O. Note it all of you, more salt is a double salt which contain ferrous sulfate and ammonium sulfate. And where we studied more salt, we studied what is the difference between a coordination compound and double salt. Coordination compound do not undergo complete dissociation in water or in solution, whereas double salt undergo complete dissociation. So what is chemically more salt? FeSO4, NH4 twice SO4 along with 6H2O, option B. EDTA is used for the estimation of, we studied in the last part the application of coordination compound. EDTA is used in the determination of hardness of water. Hardness of water, right? EDTA is used for the quantitative analysis, checking the hardness of water. They are asking you what is hard water. You know, hard water contain calcium and magnesium ion, right? Calcium and magnesium ion. EDTA is used for the quantitative analysis. Which one? Checking the hardness of water. Then the solution of the complex, this complex, what is the complex given? CuNH3 4 times SO4 in water will give the test of copper ion NH4. Very simple, my dear, very simple. See, copper and amine, they do not come out. Sphere do not break. Only what is present outside, that is counter ion. Counter ion can undergo complete reaction. So it can give you the reaction of which one? Sulfate ion. Give the test of sulfate ion. For example, if you treat this compound with a barium chloride, this barium combined with the sulfate, you will get barium sulfate, white precipitate. White precipitate. Remember, only counter ion can undergo complete reaction. Okay. Now, consider the following isomers. You can able to see so many compounds are given here. In this, consider the following isomer. Which of the following observation is correct? Okay, correct. Let me check it once again. Which of the following observations are correct? First one, give a pale yellow color. See, this all are not isomer actually. See, the formulas are having difference here. So, these two are okay. Anyway, first one will give pale yellow. And second one will give white precipitate with a silver nitrate. Is it? If you treat it with a silver nitrate, you will get this AgBr. Yes, AgBr color is yellow color. If you treated this with the AgNO3, you will get AgCl. Remember all, AgCl color is white color. So first one give you pale yellow and second one give you white precipitate with a silver nitrate. Yes, that is correct. A is the correct one. Remember, AgBr color is yellow color, AgCl is white in color. Now, the number of ions given by this complex in aqueous solution is, yes, it is compulsory to know how to break into their ions, my dear. Carefully listen. Carefully listen. You know how to break into their ions. This is complex, right? This complex, you please don't treat it as a big compound. This is just one species, one ion. So this complex I can write 1 time and chlorine is already 4 times. And you know this 1 come from chlorine and this 4 come from this one, right? You know the ions making first one cation, second one anion. So we can write 1 this complex. What is the complex? PTNH3 6 times 4 plus 4 chlorine with a charge -1. Total 1 plus 4, total you are getting 5 ions. So what is answer? 5. The number of ions given by this complex is which one? 5. That's it. When 1 mole of each of the following complex is treated with the excess of silver nitrate, when this complex is treated with the excess of silver nitrate, definitely you will get AgCl because this Ag combined with this Cl, right? The outermost Cl. Which will give maximum amount of AgCl. Very simple. Where maximum chlorine outside, that will give you more AgCl. Here 3 chlorine, here 2 chlorine, here 1 chlorine, here no chlorine. So which will give, this will give you 3 moles of AgCl. Remember, how many chlorine are present outside? Same amount of AgCl can get it when you treat it with a silver nitrate. Complexes in increasing order of their conductivity. Already we discussed the one which is giving more number of ions can conduct more electricity. See, this is only coordination sphere. It won't give any ion. And this complex is just like a NaCl. You consider 1. So this complex is CONH3 4 times Cl2 plus 1 and Cl minus 1. 1 plus 1, total it's giving you 2 ion. Dear all, this is just like a NaCl, okay? This is, you consider this one as Na, this is Cl. It will give you Na plus Cl minus, like that, this plus this Cl minus, that's it. And this one we can write it as complex, this one time, this 3. You know, this 3 come from this side, the 1 come from this side. So you will get one complex with a CONH3 6 time 3 plus plus 3 Cl minus 1 plus 3, total is giving you 4 ions. What about this case? This I can write complex 1. This 2 come from here, this 1 come from here. So 1 complex CONH3 5 times Cl whole 2 plus plus 2 Cl minus, total 1 plus 2, it's giving you how many? 3 ions. Here, no ion. The one which is giving more number of ion can conduct more electricity. So what is the order, my dear? Third one is the highest. Third one is the highest. Then fourth one. 3, 4, 2, 1. Yes, option A. The one which is giving more number of ions can conduct what? More electricity. So third one is most highest because third one having more ion. Then the fourth one, second one. Correct. A coordination compound having the formula CrCl34H2O. So chromium is the metal atom. Chlorine and aqua can be the ligand. It gives a white precipitate of AgCl with a silver nitrate. The molar conductance of the compound corresponds to 2 ion. It's giving you, the complex is giving you 2 ion. And what is the complex? Very simple. Which is giving 2 ion here. See, this won't give you 2 ion. This is only the complex. Cut it. And they already said it will give you AgCl. Will it give AgCl? No, there is no chlorine outside. Cut it. It can give you 1 AgCl. It can give you 2 AgCl because 2 chlorine outside. But they said overall the complex will give you 2 ion. Yes, this one. This complex, how you break, my dear? This is 1, 1, right? This is CrH2O 4 time Cl2 plus 1 and Cl minus C1 plus 1, total 2 ion. 2 ion is given by option C. You check it with this one, it will give you 3 ion because 1 complex and 2 chlorine, 3 ions are produced. They already said 2 ions should be formed. According to Werner's theory, what is Werner's theory? According to Werner's theory, they said the central metal atom possesses 2 types of valency, primary valency and secondary valency. Primary valency give you the oxidation state and secondary valency give you the coordination number. Primary valency is also called ionizable valency. Secondary valency is also called non-ionizable valency. So first one, question, according to Werner's theory, primary valency is ionizable. Yes. Secondary valency is non-ionizable and primary valence both are not. No. So primary valency is ionizable, secondary valency is non-ionizable. Fill in the blanks according to Werner's coordination theory. There are dash kind of valency. There are 3 different 2. There are 2 type of valency, my dear, primary and secondary. So there are 2 type of valency. So answer is either C or D. Dash and dash, that is what primary and secondary. Primary and secondary. Primary valency of a central metal ion satisfy with what? Primary valency. Primary valency means what? The oxidation state. Oxidation state depends on what? The charged ligand. That means anions, right? So 2 primary, secondary, anion. See, cation is not possible, right? You know, the primary valency means what? Oxidation state. When you calculating the oxidation state of a central metal atom, we need the negatively charged ligand because neutral charged ligand won't contribute any charge to the oxidation state, right? Now, ammonia act as a very good ligand. You know what is ammonia? NH3. You know, it act as a very good ligand because it can donate the lone pair. It's electron rich. Whereas ammonium ion, what is ammonium ion? NH4 plus, do not form complexes. Why? Simple question. You know, ligands are either negatively or neutral charged species. Positive charge is not allowed, right? So ammonia, why it is a ligand means because it's having lone pair, it can donate to the metal. Amine is a gas, no. Ammonia undergo sp3, no. Ammonium ion does not have any lone pair. Yes, therefore, ammonium ion does not carry any lone pair, but ammonia that contain lone pair. A ligand is given here. Let me just expand, my dear. This N CH2, CH2, NH2. Like how many are there? 3 are there, right? CH2, CH2, NH2. And we have one more CH2, CH2, NH2. All right. These are the three ions given here. This is a ligand given. What is the denticity? How many donor atoms are there? That's a question. See dear, all nitrogen carry lone pair. All are donating site. You check whether there is a negative charge or neutral charge. Neutral charge in the sense that's contain lone pair or not. Those sites are donor atoms. So 4 lone pair is available. So 4 donor atoms are there. So it is a tetradentate ligand. Now, among the following, which are ambidentate ligand? You know very well what are ambidentate ligand. Ambidentate ligands are certain monodentate ligand having 2 donor atom, but at a time they use only once. You know, CN, NC are ambidentate ligand, SCN, NCS ambidentate ligand, and we have a NO2 and ONO as ambidentate ligand. Which of the following are ambidentate ligand? SCN, NO3 no, NO2 oxalate no. So 1 and 3 are allowed. 1 and 3 are. Which are the following ambidentate? SCN and NO2 minus. Which of the following ligand form a chelation? Chelation is formed by bidentate or polydentate ligand. You know, acetate. Acetate is what? CH3COO minus. It is a monodentate ligand. Oxalate, yes, oxalate is a bidentate ligand. You know, cyanide monodentate, ammonia is also monodentate. Which of the following is not a neutral ligand? Which of the following is not a neutral charge? Aqua, you know, neutral, amine, neutral, ONO minus, NO2 minus. These all are negatively charged ligand. And carbonyl ligand also, you know, neutral charge. Which of the following ligand will not show chelation? Will not show chelation. That means it's not a bidentate or polydentate ligand. What is that? That is option D, SCN. SCN is a monodentate or ambidentate ligand. It cannot form to this. What is DMG? Dimethyl-glyoxime. DMG what? Dimethyl-glyoxime. It's a polydentate type. You know, EDTA hexadentate, ethane 1,2-diamine, bidentate. A coordination number. What is the coordination number and oxidation state of the element E in the complex? Another same type of question we discussed before. First, we can calculate coordination number. E is the metal, En twice. What is En twice? 2En. And oxalate, the total 6 is the coordination number. So 6 is the starting. What is the oxidation state of the metal? EX. En is neutral ligand. Oxalate charge -2 and nitro charge is -1. Overall is equal to +3. Yes, 6 is the coordination number. 3 is the oxidation state. 6 and 3. Yes, let's go with option A. I think the same one, another question we discussed. Now, identify the statement which is not correct. Coordination compounds are mainly known for transition metal. Correct. Because, you know, coordination complexes are mainly formed by our D block elements, right? Because of the availability of the vacant d orbital. Correct. Coordination number and oxidation state of a metal are same. No. It is not compulsory. Coordination number can be 6 or 4 like that. Oxidation state can be even 0. So here, even in the previous case, see, coordination number and oxidation state not compulsory to make it same, right? That can be different. So that is a not a correct statement. Which of the following rule is not correct as per their IUPAC nomenclature? You studied lots of rule for naming coordination compound. Cation is named first and then anion. Of course, always cation name first, then anion. In coordination sphere, ligands are named alphabetically. Yes. Positively charged ligands have suffix 8. What is positively charged ligand, my dear? That is wrong. Ligands are either negatively or neutral charged species, right? Positively charged ligands are not there. And what is the correct IUPAC name of the complex? Let us start. Potassium is first, right? So potassium, now total 5 cyanido, right? So we can say pentacyanido or cyano. Pentacyanido. What is NO? Nitrosyl. So potassium, pentacyanido, nitrosyl. Fe is in the anionic part. Therefore ferrate. What is the oxidation state? 3 potassium charge is 3. Fe charge X. 5 cyanide charge is -5. NO is neutral. Overall 0. X is equal to +2. So where is this complex, my dear? Check it all. Check it all. Potassium pentacyano or cyanido nitrosyl ferrate 2. Yes, let's go with option A. Now, what is the correct formula of the complex? They ask you name to structure, structure to name. Okay, careful. Tetraamine. What is tetraamine? NH3 4 time. Chloro, that means one chlorine is there. Nitro means NO2 or we normally call nitrito N. Platinum, PT is the metal atom. And 4 is the oxidation state and sulfate is outside. We need to get overall charge 4, right? Please check it all. Platinum, hexa, amine 0, 1 chlorine minus 1, NO2 minus 1, sulfate is minus 2. Yes, overall we are getting plus 4. No need to make any adjustment. So where is this complex, my dear? Check it. PT, NH3 4 time, ONO, no. And PT, NH3 4 times Cl2, 2 chlorine not required. PT, NH3 4 times Cl, NO2, SO4. Yes, option C is the correct one. Which among the following will be named as dibromido? What is dibromido? Br2. Bis ethane 1,2 diamine. That means what? En twice. And what is the central metal atom? Chromium. And is there any counter ion? Yes, bromide. But overall charge we need to make it 3. Okay. So as per now, let me write chromium X, 2 bromine minus 2, En 0, 1 bromine. Overall, yes, overall we are getting actually plus 3. So no need to make any adjustment. So where is this complex? Cr, En twice, Br twice, Br. Option A is correct, right, my dear? Check it all. Bis, right? Bis, yes, En. This is tris. This is, yes, that's all. The formula of the complex again, diamine. What is diamine? NH3 twice. Diamine chloro. Chloro means Cl. Only ethylene diamine. Okay, that means only one En. Nitro. What is nitro? NO2. That you can write a random order, no issue. Then what is the central metal atom? Platinum. 4 is the oxidation state and chloride is outside. Let us check it whether 4 is getting or not. So platinum X, amine neutral, chlorine minus 1, En neutral, NO2 minus 1, 1 chlorine minus 1, overall 0. But here, dear all, you will get only plus 3. But we want to get plus 4, right? So if you want to make it plus 4, what we can do it? You can put 2 chlorine here. So it become minus 2, it become plus 4. Counter ion, if there, you can adjust the number of counter ion, right? So this is an allowed one. This is an allowed one. So let's go with which option is this? PT, NH3 twice, Cl, En, NO2. Yes, option A itself, that is correct. Now, the name of the compound is, amine is there, nitrito is there, chlorine is there. Okay, let's start. Pentaamine, right? Total 5 amines are there. Pentaamine, and nitrito. What is NO2? Nitrito N or nitrito or nitro. Then who is the metal? Cobalt is the metal. Cobalt. What is the oxidation state of cobalt? Cobalt X. Amine 0. NO2 charge minus 1. 2 chlorine charge minus 2. Overall is 0. X is equal to what? Plus 3. So 3 and outside we have chlorine. So we can write chloride. So check it all. Where is this answer, my dear? Pentaamine. We won't write pentaamino. That's wrong. Pentaamine. Nitro. That's okay. Nitro. Chlorido. No, chlorido is not inside. Pentaamine, nitro, cobalt 3 chloride. Yes, option C. Yes, option C is the correct one, right? Check it all. Which of the following will not show geometrical isomerism? What is geometrical isomerism? Cis-trans isomerism. Correct, my dear? Cis-trans isomerism is given by 2 complexes. Please note all. Square planar complex will show with the type Ma2B2 type. Whereas octahedral complexes with the type Ma2B4 can show cis-trans isomerism or geometrical isomerism. You check it. This is Ma4B2 or Ma2B4 type. Yes, this will show. But which is the question which you do not show? And this is a type Ma4B2. Check it all. This is En, okay? En twice mean B4 because 4 site it will give you. That will show. And what is this? Ma5B. Yes. This one do not show. What about this one? This is Ma2B2 type. It also shows. Which do not show geometrical isomerism. Option C. Remember, cis-trans isomerism mainly given by square planar and octahedral complex. Square planar the type Ma2B2, octahedral the type Ma2B4 or Ma4B2. Clear all of you? Let's go for question number 51. For the square planar complex MABCD, what is meant by MABCD? M metal connected to 4 different ligands. The type MABCD, this point you please keep in mind all of you. In square planar, we already discussed, the type Ma2B2 show cis-trans isomerism. But the type MABCD, if in square planar complex, if all the 4 ligands are different, then it will show total 3 isomers. Number of possible isomers are 3 isomers. Keep in mind, in square planar complex, if all the 4 ligands are different, it will show you total 3 types of isomers. Which of the following complex species is not expected to exhibit optical isomerism? Optical isomerism, in order to show, first condition, bidentate ligand should be there. Bidentate ligand should be there. Very simple. This is a bidentate ligand, bidentate ligand, bidentate ligand. Option, this one you check it all. This one no bidentate ligand. Both are monodentate ligand. It is a type Ma3B3. We discussed before. Ma3B3 show which isomer? FAC and MER isomer, facial and meridian. It do not show optical isomerism. Now, this complex shows 2 geometrical isomerism, cis and trans. Let me draw the cis and trans isomer of this one, my dear. You know how to place it, cis isomer. Cis meaning NH3 and Cl. Okay, let me place it NH3 and Cl. Then we have En and En. Let me place it like this. This is cis isomer. And trans mean, how can we draw it? Trans mean we can place like this one. We can place it one NH3 here, the Cl here, and other 2 side En. This is what? Opposite, therefore it is what? Trans. This is the cis isomer, this is the trans isomer. And what is the question they asking you? Question which statement is correct? Trans isomer will show optical isomerism. See, trans isomer is this one. If you take the mirror image of this one, you will get the same image, and that will be superimposable. If it want to be optically active, the mirror image should be non-superimposable. So trans isomers are basically not optically active because their mirror image is same, they are superimposable. But this is cis isomer. If you take the mirror image of this one, it will be another image, so they are non-superimposable, and cis isomer will show optical isomerism. Keep in mind all of you, among cis and trans isomerism, cis isomerism will show the optical isomerism because cis isomers are, their non-superimposable mirror images. Next question, 2 isomers are given here with the type Ma3B3. Hope you get it. Ma3B3 mean it is FAC and MER isomerism. And the figure is also given here. The isomerism classified. Dear all, this is FAC, this is MER. What is the difference between them? FAC with the meaning, the 3 ligands will be adjacent. FAC meaning 3 ligands should be adjacent. If you connect all these 3 ligands, you will get a face there. Can you get a triangle face there? That's called FAC isomer. MER isomerism means 2 ligands adjacent, 1 ligand other side. Means if you connect, you will get a hemisphere. That's called meridian. So 3 ligands adjacent, that will be FAC. 2 ligand adjacent and 1 ligand other side, that will be MER. So one is FAC and second one is MER isomerism. Question, identify the isomerism. So first one is FAC, second one is MER. Which of the following compound exhibit linkage isomerism? As I told you, in order to show linkage isomerism, there should be the presence of ambidentate ligand. Where is an ambidentate ligand? This is bidentate, this is monodentate, this is monodentate. See, NO2 is there. What is the NO2 ambidentate ligand? ONO. Yes, C can form linkage isomerism. This complexes, you can see here, 2 coordination spheres are given here. 2 coordination sphere mean directly we studied that will show coordination isomerism.
And what is the isomer of this one is given here? Tell me, check it all of you. Here what is happening? This platinum and copper get interchanged. The species are interchanging between two coordination sphere, what we call coordination isomerism. And okay, next one. Which of the following isomer will give white precipitate with the barium chloride? Barium chloride, if you are treating, if it forming white precipitate, mean barium sulfate is the precipitate. So where is sulfate outside? Here. So answer is B. What is the point? If a compound, when you treated with a barium chloride, if they are saying that there is a white precipitate, the white precipitate is nothing but barium sulfate. Barium sulfate. So this barium combined with this sulfate, here bromine is the present, not give you white precipitate. Barium chloride, if you are treating, white precipitate is forming, then barium sulfate is the species. Now, few isomers are given below. Mark the correct statement regarding this. CrH2O 6 times Cl3. This example we discussed in our hydration isomerism. And one here, what happened to here H2O 6 time, here H2O 4 time, and then here actually one H2O outside. Here one chlorine will be there, okay, and H2O 4 times Cl2. So here 2 H2O outside, 2 H2O outside, and chlorine, okay. So when you check these formulas, when you check the formula, their molecular formula are same, but here 6 H2O as ligand, 4 H2O as ligand, and here we can place it the another isomer, okay. I'm just marking a correction here. H2O 3 time, here we have H2O 6 time. Okay, let me just arrange these complexes once again, okay, my dear. So complexes are, there is a small mistake I think. CrH2O 6 times Cl3, one complex. Here how many H2O as ligand? 6 H2O as ligand. Now let me place one H2O outside, one chlorine inside. So CrH2O 5 times Cl, Cl2, one H2O out. Now 2 water outside, 2 chlorine inside. CrH2O 4 times Cl2, 1 Cl outside and 2 H2O outside. These complexes we studied under the area hydrate isomerism. Because of the hydrate isomerism, it showed different color. We studied that this complex is violet in color, this complex is gray-green in color, this is dark green in color, right? Because of hydrate isomerism. So question they are asking you, 1, 2, 3 are hydrate isomer, 1, 2, 3 are coordination. They are actually belongs to which isomerism? Okay, you cut these complexes, you select these complexes as the question. 1, 2, 3 are hydrate isomerism. Because of hydrate isomerism, they shows different colors also. That is one another previous question. Check it all of you. Which of the following pair of isomer is not correctly matched? Isomerism questions are very sure important question, my dear. Be careful. Which is not correctly matched, okay. This, see, this is 2 coordination sphere given, see coordination sphere given, that is what coordination isomerism, correct. And this is what linkage isomerism mean ambidentate ligand or not, check it. Here NO2 is there, here ONO is there, yes, correct. And here they are saying that coordination isomerism, is it coordination isomerism? No, this is the correct answer. See, coordination isomerism mean there will be 2 coordination sphere from which the species are interchanging. Here you see this is one species, this is one another species. No. What about the last one? Ionization. Yes, see that bromine and chlorine get interchanged here. That is our ionization isomerism. So what is the answer? C. And CrCl3 6H2O exist in different isomeric form which show different colors like violet, green and all. This is due to what? Hydrate or solvation isomerism. I just discussed now the complex, which one? CrH2O 6 times Cl3, violet color. If H2O outside, gray green, dark green. The color of isomerisms, different compounds having different color here is because of presence of H2O ligand in different number. That is hydrate isomerism. Match the column 1 with the column 2. All of you carefully notice. This column 1, which isomerism is this? You can clearly notice that 2 coordination spheres are given. 2 coordination sphere mean coordination isomerism. Then second one, This is given NO2ClBr. You know, Cl and Br can interchange, right? Cl and Br can interchange. They can show ionization isomerism. But ionization isomerism, I think, is not given here. Okay, let us go with another. Can you able to see En twice is there? Even NO2 is there, my dear. NO2 is there. NO2 is what type ligand? Ambidentate ligand. So it can show linkage isomerism. And another one, let us possible, PTEN twice Cl2. This is a type MA4B2. MA4B2 show cis trans isomerism or geometrical isomerism. And what about the last one? CN2 NH4 twice. Then optical isomerism is remaining, right? Okay. Then wait all of you. Then we have to make some rearrangement here. Some rearrangement here not matching. So A we can definitely match with the coordination isomerism because two coordination spheres are given here. That is coordination. I think that is only one option is given. C. A is matching with one third one. Then B they said with the fourth one. Okay, NO2 is there, so linkage isomerism, that's also correct. C is given as which one? Optical. Okay. En twice is there, right? This is a type which one, my dear? MA4B2. We studied MA4B2 can show cis and trans isomer, where cis isomer is optically active. Yes, so optical isomerism possible. And this is a type of MA2B4. Yes, it can show which one? Geometrical isomerism. Yes, correct option. C is the most suitable one. Next one, mark the incorrect statement. Inner orbital low spin complexes involved in D2sp3. What all cases we studied in octahedral complexes? We studied octahedral complexes can be the hybridization D2sp3 or sp3d2. If it is D2sp3, they are called inner orbital complex. Inner orbital complexes are also called low spin complexes. sp3d2 mean they took outer d orbital, so therefore they are called outer orbital complexes or high spin complexes or high spin complexes. This is the theory we studied according to VBT. Check it. Inner orbital low spin complexes involve D2sp3. Correct. They are asking which is incorrect. Outer orbital, that means high spin complexes involve sp3d2. Correct. Tetrahedral complexes generally involve dsp2. No, tetrahedral complexes, what is hybridization, dears? sp3. So this is the incorrect statement. Which of the following facts about the complex is wrong? So they are asking about the shape and all. So let us calculate faster. They given that CrNH3 6 times Cl3 is given as the complex, right? Which is wrong? That's a question. Let us go for the complex. You know the step 1, step 2, step 3 calculation of VBT. Let me take the central metal atom chromium. Chromium atomic number is 24. We can write it as argon 4s2 3d4. No need to interchange the half-filled configuration. Okay, anyway you are going to remove electron, right? Here what is the charge of chromium? Chromium X, amine 0, 3 chlorine minus 3, overall 0, X is equal to plus 3. So chromium charge is plus 3. What do you mean by plus 3? Remove this 2 and from this one you will getting 3d3, 4s0. 3d3, 4s0. And you know amine is a strongest ligand. If amine is a strongest ligand, we have to pair the electron, right? D3. D3 means what? 1, 2, 3 and 4s is free now. See, if you pair, you know, amine is a strong ligand. If you pair it, it is very clear it is an octahedral complex. Why it is an octahedral complex? Because the coordination number is what? 6. If it is an octahedral complex, either it should be sp3d2 or d2sp3, correct? So here, if you consider amine is a strong ligand and if you pair it, these all electrons get paired, it become 3d orbital will be free. So it comes starting with a d3 something. Such hybridization not there. So even though there is a strong ligand, we studied some exceptional cases. Even though amine is a strong ligand, here no need to pair it. So you can go to the hybridization, which one? You can take 1, 2, 3, 4, 5, 6. What is hybridization? D2sp3 can be selected. D2sp3. So check it all. The complex involved D2sp3 hybridization and is octahedral in shape. Yes, correct. The complex is paramagnetic. Yes, that's having unpaired electron, correct. The complex is an outer orbital complex and complex give white precipitate with a silver nitrate. Can it give white precipitate with a silver nitrate? Yes, right? Is this complex give white precipitate with a silver nitrate? Because a silver nitrate, if you treated silver combined with the Cl, you will get AgCl. Yes, white colored precipitate. So which is the wrong statement? C, it is the complex is an outer orbital complexes. No, the hybridization is come as D2sp3. So it should be a inner orbital complex. Now the complex ion which has no d electron in the central metal ion atom, where there is no electron in d orbital. Check it. First complex, let me take it as MnO4, which is the central atom Mn. Mn atomic number is 25. We can take it as argon 4s2 3d5. Here manganese charge you calculate, my dear. Mn charge is x. One oxygen charge is -2. So 4 oxygen -8. Overall -1. X is equal to +7. Correct? So +7 mean remove all those 7 electron. See, there is no d electron. So all the d electron is lost, right? So there is no d electron. Option A can be the correct one. What is the question, my dear? Once again, the complex ion which has no d electrons is, no d electrons means what? The d orbital contain no electron. Here Mn is the central metal atom. Mn charge is +7. +7 mean all those 2 and 5, 7 electron gone. There is no d electron. Now give reason for the statement why NiCN4 2- is diamagnetic while NiCl4 is paramagnetic. Very simple question, my dear. NiCN4, which is the ligand here, cyanide. Cyanide is a strong ligand, whereas Cl is a weak ligand. So strong ligand if present, electrons undergo pairing, there won't be any unpaired electron. So it can be diamagnetic. If there is a weak ligand, no pairing of electron, so enough unpaired electron will be there. It is paramagnetic. Where is that answer? NiCl4 2- no unpaired electron, no. NiCN4 2- no unpaired electron are present, while NiCl4 2- 2 unpaired electrons are present. NiCl4 2- shows a DSP to hybridization, hence it is paramagnetic. No, NiCN4 2- shows sp3 hybridization, hence it is show diamagnetic. No, mainly the diamagnetic and paramagnetic is based on what? The presence of strong ligand and weak ligand. So this complex, no unpaired electron are present, while in NiCl4 2- 2 unpaired electrons are present. Therefore it is what? Paramagnetic and diamagnetic. COF6 3- is, they are asking you the geometry and all. Okay, dear all, let us calculate faster. What is the species? COF6 3-, which is the central atom? Cobalt. Cobalt atomic number is 27, so we can write it as argon 4s2 3d7. What is the cobalt oxidation state? X, 6 fluorine -6, overall charge -3, X equal to +3. So cobalt charge is +3. What is meant by +3? Lose this 2 and 1, so remaining is 3d6 and 4s0. Okay, 3d6, let me write it here. How you write 6 electron? 1, 2, 3, 4, 5, 6 and 4s is free now. Fluorine is a weak ligand, so no pairing happen. So total 6 vacant orbital we need because 6 ligands are there. Only 1 is free. So let me take it after 4s who is free, 4p, after 4p which is free, 4d is free. So let me take 1, 2, 3, 4, 5, 6 orbital. What is hybridization? sp3d2. sp3d2. Check it all. Is it paramagnetic? Yes, it's highly paramagnetic because more unpaired electrons are there. So they are paramagnetic and undergo sp3d2 hybridization. Yes, correct. No, diamagnetic, paramagnetic and undergo sp3d hybridization. No, diamagnetic, no. So VBT related questions are very important, my dear. So step 1, ground state. Step 2, oxidation state. Step 3, identify the ligand, whether it is strong or weak. As here it's a weak ligand, so no pairing. So we got the hybridization sp3d2. Next, which of the following has largest paramagnetism? Largest paramagnetism means they contain more number of unpaired electron. Okay, more number of unpaired electron. Option A, central atom is chromium. Chromium is 24. We can write it as argon with the 4s2 3d4. Here chromium charge is 3 plus. 3 plus means this 2 and 1 goes. 3d3 is remaining. And H2O is a weak ligand. So this 3 electron won't pair it. So there will be 3 unpaired electron. First case. Second case is given as iron. Iron atomic number 26. So configuration we can write it as argon 4s2 3d6. And here Fe charge is 2 plus. So Fe 2 plus mean lose these 2 electrons. So 3d6 is remaining. And H2O is a weak ligand. So 6 electron how they occupy? 1, 2, 3, 4, 5, 6. There are 4 unpaired electrons. Alright. Let us go to the third system. Copper is the metal atom. Copper atomic number is 29. So that is argon with 4s2 3d9. And here copper charge is 2 plus. So this 2 gone, 3d9 is left. Aqua is a weak ligand. So 9 electron, how they exist, my dear? 1, 2, 3, 4, 5, 6, 7, 8, 9. Only one unpaired electron is there. Only one unpaired electron. And last one is given as D, that is zinc atomic number is 30. So the configuration is argon 4s2 3d10. Here Zn charge is 2 plus. So Zn 2 plus means these 2 electron gone. They are all D10. D10 means all the orbitals are, which one, how many? 2 electrons are there. There is no unpaired electron. Question, which of the following has largest paramagnetism? Largest paramagnetism means the one which contain more number of unpaired electron. Where you can able to see more unpaired electron? First 3, 4, 1. Yes, that B is the more one. Now, using valence bond theory, the complex can be described as, what is the complex? CrH2O 6 times 3 plus is the complex. Let us start the structure. Chromium is the metal atom. Its atomic number is 24. So configuration is argon. Then 4s2 3d4 is the configuration. Here chromium charge is which one? 3 plus. So chromium 3 plus means this 2 and this 1 gone. 3d3 and 4s0 is remaining. H2O is a weak ligand. So electrons do not undergo pairing. So we can write 1, 2, 3 and 4s is here. This is 3d, this is 4s. Total 6 ligand we have to place it. So 6 vacant orbital we need. We have only 3 now. So after 4s, we can take it 4p. So 1, 2, 3, 4, 5, 6 we can take it. So you will get sp3d2 octahedral complex, right? So what is the answer? It is sp3d2, and sp3d2 means outer orbital complex and high spin. I think which can be described as option A is correct, right? sp3d2 out and its outer orbital complex and paramagnetic. Yes, unpaired electrons are there. So all are related to VBT. Now, which of the following complexes will show maximum paramagnetism? I told you maximum paramagnetism means they contain maximum number of unpaired electron. What do you mean by D4? D4 means d orbital contain 4 electrons. So what is the unpaired electron? 4. D5, D5 means how the electron access 1, 2, 3, 4, 5. The number of unpaired electron is 5. D6, what do you mean by D6? D orbital contains 6 electron. 1, 2, 3, 4, 5, 6. Only 4 unpaired electron. What about D7, my dear? D7 means 1, 2, 3, 4, 5, 6, 7. Only there will be 3 unpaired electron. So which of the following complexes will show maximum paramagnetism means the one which contain more unpaired electron? That is D5. 5 unpaired electrons are there. Hope you can follow me. And what is the electronic configuration of this complex on CF, CFT, the theory, T2G and EG, how to place the electron? The complex is given as Cu, central metal atom is copper. Copper atomic number is 29. What is the configuration? 4s2 3d9 with argon. Here copper charge is 2 plus. So 2 plus means this gone. What is remaining? 3d9. And amine is a strong ligand, my dear. Strong ligand mean how 9 electron access? 1, 2, 3, 4, 5, 6, 7, 8, 9. Already 9 electron. Even if you pay it, it will access like this. Correct? So how you are going to split this one? How you are going to split this one? In octahedral complexes, how the splitting is happening. First 3 orbital goes down. First 3 orbital goes down. Last 2 orbital goes up. You know, this is called T2G and this is called EG. How many electron in T2G? 6 electron. EG only 3 electron. T2G 6, EG 3. Option B can be suggested. T2G 6 and EG 3. This is the crystal field theory related question. Now, what is the correct energy level diagram for the complex here? Again, cobalt is the metal, 27 is the configuration. Cobalt 27, what is the configuration we can write? We can write argon with 4s2 3d7. Here cobalt charge you calculate all of you, you will get cobalt 3 plus. Cobalt 3 plus means this 2 and this 1 gone, remaining 3d6 and 4s0. And 6 electron, how you can write it? 6 electron, normally we can write 1, 2, 3, 4, 5, 6. But cyanide is the ligand. You know, cyanide is a strong ligand, so electrons undergo pairing. How 6 electron get pair, my dear? 6 electron, why like 2, 2, 2. Now you break down. Now you break into what? First 3 goes down, first 3 goes down, last 2 up. You know, T2G 6 electron, here EG no electron. Where you can find that configuration, my dear? Check it all. Check it all of you. That is 6 electrons are there. T2G 6, EG 0. That is option B. See, T2G 6, EG no electron. Because cyanide is a strong ligand. Electrons undergo pairing. Now FeF6 3- is paramagnetic due to the presence of unpaired electron in the complex. The 5 electrons remain unpaired because, why it is paramagnetic? Because fluorine is a weak ligand. Since weak ligand present, they do not undergo pairing, so they exist as unpaired electron. So fluorine is the most electronegative element. That's a correct statement, but not the reason here. Fluorine is a weak ligand. So fluorine is a weak field ligand, hence does not cause pairing of electron. Yes, therefore. Now, the increasing order of their crystal field splitting strength. We studied spectrochemical series. One question in part 1 video we already discussed. Can you tell me what is the correct order of their crystal field splitting energy or the spectrochemical series? What is the correct order? You know, carbonyl is the most strongest ligand, then cyanido, then amine, then aqua, then only halogen comes. C is the correct order. Study the spectrochemical series thoroughly, my dears. The geometry possessed by this complex is, okay, let us calculate. Here nickel is the central atom, 28 is the atomic number. We can write it as argon with 4s2 3d8. Here nickel charge is 0, right? Because carbonyl is a neutral ligand. Nickel charge is 0, no oxidation state. So let us go for carbonyl, my dear. Carbonyl is a strong ligand. If there is a strong ligand, you know, electrons undergo pairing. So how D8 and 4s2, what happened? These 2 electron also come inside 3D, so it will become 3D10. 3D10 means how you can fill the electron? 2, 4, 6, 8, 10. All outermost electron come inside and get paired. So total, you know, 4 ligands you have to accommodate. 4 ligands if you want to accommodate, 4 vacant orbitals are required. 3D already full. After that we can take it which one? 4s and 4p we can take it. So 1, 2, 3, 4. What is hybridization? sp3 is the hybridization. sp3 means what is the shape, my dear? Tetrahedral is the geometry. According to VBT. These all are related to VBT and CFT. Now CRC bond in the compound CrCO6 shows pi character due to, we studied that Cr, you know, metal when combined with the carbonyl ligand, any metal combined with the carbonyl ligand, they have a ability to form pi bond. You know, pi bond mean 1 sigma bond, 1 pi bond. And the pi, in the double bond, 1 sigma bond and 1 pi bond. So metal carbonyl, a special case we studied. Carbonyl ligand have an ability to form double bond with the metal, and the extra bond, what we call it as synergic bond, right? Synergic bond or self-strengthening bond. So what is the question? The CRC bond in compound shows pi character. That is because of what? Synergic bonding. That is because of synergic bonding. That is the extra pi bond is called what? Synergic bond. Question number 76. Mark the incorrect match. If we studied in biology, where these coordination complexes are using in biological system, we studied hemoglobin, iron is the central atom. Chlorophyll pigment, magnesium is the central metal atom. And vitamin B12, cobalt is the metal atom. And one more I am introducing you, insulin. Insulin, zinc is the metal atom. Hemoglobin, iron, it is correct. Vitamin B12, cobalt is correct. They're all chlorophyll pigment, not chromium, it is magnesium. So this is the incorrect match. Match the column 1 with the column 2. Okay, let us go for that. First one. Estimation of hardness of water. We studied hardness of water is calculating by the titrating with the EDTA. EDTA. So this is with the A. A with the 2. A with the 2. Option B. Anyway, detection and estimation of nickel. Qualitative analysis we are using DMG. Dimethyl glyoxine. DMG. This one. This is B. Electroplating is there. Cancer treatment is there. I think the cancer treatment you may studied cisplatin, right? That is D. And electroplating is which one? Potassium dicyanoargentate. So basically, the except this electroplating, all others are mentioned in textbook. So that overall answer is A2, B3. Yes, correct. Now both geometry and geometrical means what? Cis-trans and optical isomerism are shown by. Both geometrical and optical isomerism are shown by the type, remember, MA2B4 type. MA2B4 type can show both geometrical and optical, especially the cis isomer. Okay, which type is this one? This is MA5B, no. MA4B2, MA, not that. So I think option A is correct. And remember, in order to show optical isomerism, bidentate ligand also should be there. Therefore, I selected this one. See, this type is given as COEN twice, Cl twice. See, this complex is given the type MA4B2. Why MA4? Because En is a bidentate ligand. So, En twice mean 4 times. Okay. This type, let me draw the shape. Okay, CO. This will show cis isomer, right? MA4B2 shows geometrical isomerism. That is very clear. But how it show the optical isomerism? Let me draw Cl, Cl. This is what? En, En. This is the cis isomer. And if you place one Cl up, one Cl down, En, En this side, it will be trans. You know, cis isomer, when you take the mirror image, it will be different and they are non-superimposable. Correct? So the type MA2B4 with a 2 bidentate ligand, definitely they show geometrical isomerism as well as optical isomerism. So option A is the correct answer. Why it is not? This is a type MA5B, do not show. This is a type MA4B2. It will show cis-trans isomerism, but optical isomerism cannot show because no bidentate ligand. This can show optical isomerism because bidentate ligand is there, but it cannot show geometrical isomerism. The color of the coordination compound depend on the crystal field splitting. What will be the correct order of the adsorption of their wavelength? Wavelength. Careful all of you. Wavelength. You want to arrange the complexes, these complexes in the order of their wavelength. You studied in 11th grade, energy is related to what? Wavelength, right? Energy E equal to hc by lambda. So energy is inversely proportional to which one? Wavelength. Correct? Energy is inversely proportional to wavelength. Careful. So higher the energy, which energy? You know, crystal field splitting energy. Stronger the ligand, or you remember like this one, my dear, strong ligand having less wavelength. Stronger the ligand, higher energy, so less wavelength. You know, amine is there, cyanido is there, aqua is there. Which is the most strongest ligand? Cyanide. Then amine, then aqua. So energy order, if you are writing, cyanide is strong, then amine is, then H2O is weak ligand. So if you want the wavelength, opposite order, aqua come first, then amine, then only Cn comes. So where is this, my dear? H2O, NH3, Cn, option C. So if they asking you the wavelength, you know, wavelength is related to the energy inversely proportional. Careful. So stronger the ligand, you know, if you want to know that spectrochemical series, we have to know. So stronger the ligand, stronger the higher the energy. Higher the energy, lesser the wavelength. So, you know, aqua is a weak ligand, therefore more wavelength. Okay, they are asking wavelength order. Now, Indicate the complex ion which shows geometrical isomerism. That means cis trans. We know geometrical isomerism is given by the type Ma2B2 in square planar, Ma2B4 in octahedral. So what is this? Yes, this is our type Ma4B2. Go with this one. Other cases are not belongs to our category. What is the correct IUPAC name of cisplatin? What is cisplatin? Anti-cancer drug. What is the formula of cisplatin? PTNH3 twice, Cl twice. This is the complex called cisplatin, my dear. What is the name of cisplatin? Diamine, right? Diamine. Then 2-chlorine, right? Dichlorido. Diamine, dichlorido. And what is the metal? Platinum is the metal. What is the oxidation state? Platinum X, amine 0, 2-chlorine -2, overall 0, X equal to +2. We can place 2 here. So where is the answer? Diamine, dichlorido, platinum 2. Yes, let's go with option A, right? Cisplatin means it is an anti-cancer drug. Formula please memorize all. Diamine, dichlorido, platinum 2. Next one. What is the experimental value of magnetic moment? How to calculate magnetic moment? Magnetic moment is calculated by the equation root of n into n plus 2 Bohr magneton. Where what is n? N is the number of unpaired electron. What is the complex given? FeCN6 4 minus. They all calculate the number of n value. How to calculate n? Apply VBT. Which is the central atom? Iron. Iron atomic number 26. So we are getting argon with a 4s2 3d6. Here Fe charge you calculate, you will get 2 plus. Yes or no? FeX 6 cyanide minus 6, overall charge minus 4, x equal to +2. So Fe2 plus means these 2 gone. What is remaining? 3d6. You know, cyanide is a strong ligand. So strong ligand if present, these 6 electrons undergo pairing. So you will get 2, 2, 2. Is there any unpaired electron? No unpaired electron. Unpaired electron 0 mean magnetic moment also 0. Root of 0 into 0 plus 2. Option C can be the answer. So root of n into n plus 2 is the equation to calculate magnetic moment, and the n value represent the number of unpaired electron. Next one. State the number of unpaired electron in the metal K4NiCN4. Okay. Who is the central metal atom, my dear? Central metal atom is nickel. Nickel atomic number is 28. We can write it as argon 4s2 3d8. Here nickel charge value calculating. You know, 4 potassium outside. So 4 potassium charge 4, nickel X, and 4 minus equal to 0. So X equal to what? 0. Here nickel no oxidation state. Okay. You know, cyanide is the ligand. Cyanide is a strong ligand. So all electrons get paired. So even the 4s2 electron also come inside. It become 3d10. 3d10 means how you fill the electron, my dear? 2, 4, 6, 8, 10. Is there any unpaired electron? No unpaired electron, because all electrons get paired. So let's go with which one? Option D. So in this case, no unpaired. Question state the number of unpaired electron. No unpaired electron. What is the formula of the complex? Potassium. What is potassium? K. Dicyanido. What is dicyanido? Cn twice. Bisoxalato. That means OX twice. Nickelate. Yes, nickel. Okay. 2. What is the overall charge? 2. We need to get it. Let me check it. As per now, it is correct or not. As per now, I placed only 1 potassium, so charge is 1. Nickel X, 2 cyanide charge is -2. 1 oxalate -2, 2 oxalate -4, overall 0. You will get it as X is equal to +5. But we need to get it as +2. If you want to make it +2, let me put it 3 potassium outside. So this will be 3. So overall it will be how much? It will be +3, right? How much we need to get it? Here 6 minus 3, not enough. I think 4 potassium is required, right? K4 is required. Then only it become a 4. So 6 minus, yes, it will be, now it will give you +2. So there should be 4 potassium outside. K4NiCN twice, OX twice, right? Option C can be the correct answer. Check it all of you, correct or not? Please cross check it, okay? So formula of potassium dicyanido bis-oxalato-nickelate. Okay, 4 potassium should be outside, then only the charge overall it will be 2. So here 4 potassium, excess, minus 2, minus 4, overall minus 2 here, yes, plus 2, correct. Next one, which is present in metal carbonyl? Which is present in metal carbonyl? What is metal carbonyl? Metal with the carbonyl ligand. We studied there is a chance to form double bond. One bond is single, one bond is pi, the synergic bond. So which is present in metal carbonyl? We can say option C, metal carbon sigma bond is there, metal carbon pi bond is also there. What is that pi bond is called? Synergic bond. How many ions are given by this complex? What is the complex given here? CONH3 5 time Br and then Cl2. How many ions can produce by this one? Let me write this complex is 1 time, chlorine is 2 time. You know these 2 come from here, 1 come from here. So 1 CONH3 5 time Br is there with the charge 2 plus and 2 chlorine with the charge minus 1. 1 plus 2, sorted it will giving you how many ion? 3 ions can be given by this complex. What is the IUPAC name of this complex? Potassium, starting with the K, right? Starting with the potassium, okay? So potassium, cyanido, dicyanide. You know silver, when it is present in the anionic part, it's called argentate, right? Argentate. What is the oxidation state? Only 1 potassium, silver hexa, 2 cyanide minus 2, overall 0, x is equal to what? Plus 1, right? Where it is given, my dear, check it all. Potassium, dicyanide, argentate 1, right? Option C is the correct answer. Now, what is the IUPAC name of the complex? K2Ni. See, there's a small difference, okay? This is KAG, here K2Ni. So here potassium is again outside. So potassium, total 4 cyanido, right? So tetracyanide, nickelate, because nickel is in anionic part. Calculate the charge, I think you will get 2. Potassium, tetracyanide, nickelate 2. Potassium, tetracyanide, nickelate 2. Option B is the correct, right? Yes. Next one. In the following chelating ligand, which is a chelating ligand, right? Chelating ligand means it should be bidentate or polydentate. OH is monodentate. Yes, this is what? This is our EN ligand. Ethane 1,2-diamine is our bidentate ligand. It's monodentate. What is the coordination number in this complex? What is the coordination number? Here all. Chromium is the metal. It is connected to oxalate. How many oxalate is there? 3 oxalate. You know, oxalate is a bidentate ligand, so that will provide total 1, 2, 3, 4, 5, 6. 6 is the coordination number. What is the oxidation state of Fe in this one? Simple question. 3 potassium. You know, 1 potassium plus 1, so 3 potassium plus 3. Iron hexa, 6 cyanide minus 6. Overall 0, x equal to plus 3. Yes, so when you're doing this question, when I'm giving you one question, pause the video, find your own answer and cross-check it, okay? Now, what is the name of this complex? Okay, start. Potassium is outside, so let's start with potassium, 3, right? So trioxalato. What is aluminium is in anionic part, right? So aluminate. Potassium trioxalato aluminate. And what is the overall charge? 3 potassium 3, aluminium hexa, 3 oxalate minus 6, overall 0, x is equal to what? Plus 3. So we can write it to what? 3. So where is the answer? Potassium trioxalato aluminate 3, right? I think option A is correct. Yes, fine. Now predict the number of ions produced per formula for the complex COEN thrice, Cl thrice. This complex, how many ions can produce? Let me write this complex 1 time, this is 3 time. This 3 come from here, this 1 come from here. So we will get 1 complex COEN thrice, overall charge 3 plus, and 3 chlorine with a charge minus 1. 1 plus 3, total it's giving you how many ion? 4 ions can be produced. So total number of ions, 4. When 1 mole of, what is the complex given? COCl3 5NH3. Okay, the complex formula is given as COCl3 5NH3 is the formula given, is treated with the excess of silver nitrate, giving you 2 moles of AgCl. Remember all, 2 mole AgCl produced mean there should be 2 chlorine outside. That's the meaning. So what is the answer? Option B. This is 1 chlorine outside, so it will give you only 1 AgCl. Okay, that's it. So when 1 mole of this complex treated with the excess of silver nitrate, 2 moles of AgCl were precipitated. What is the formula of the complex? Point is very simple. If they're giving 1 mole AgCl mean there is 1 chlorine outside. 2 moles AgCl mean 2 chlorine outside. That's it. Option. Only 2 moles AgCl, option B. Correct. Now, the absorption maxima of several species are given here. You can able to see some compounds are there. Its a wavelength is given here. Okay, this is what? The wavelength, lambda. Lambda 474, so 475 nanometer, 310 nanometer, 490. Question, what is the crystal field splitting? You know, wavelength how related to energy? Energy is inversely proportional to wavelength. Means higher the wavelength, weaker the ligand. Similarly, lower the wavelength, stronger the ligand. So this one, which one having weakest wavelength? This one. So second one having, you know, strongest ligand. Yes, this is cyanide is the strongest ligand. Then amine is strongest ligand. Then aqua. Correct. So lesser the wavelength, stronger the ligand, more splitting. So question, which one, the crystal field splitting is maximum in no doubt, which one? COC and 6 3 minus, option B. Remember, stronger the ligand, more the splitting, right? Next, assertion reason, one question I am just introducing here, the assertion. The complex ion trans, what is the complex given here? COEN twice Cl twice whole plus transform, okay, transform is optically active. My dear, it is wrong. It is wrong. Why? I am drawing the structure CO. You know how to place the trans isomer. Trans mean Cl Cl opposite, En En opposite, right? With the 2 plus 1 charge. You know, if it want to be optically active, you take the mirror image. If you take the mirror image, they are super impossible, right? They are same. So trans isomers are generally optically inactive, not optically active. Only cis is optically active. It is an octahedral complex. Yes, it's very clear. Total 6 is the coordination number, so it is an octahedral complex. So complex ion trans is optically active. That is wrong. So assertion wrong. Reason is correct one. Now, in the coordination number, what is the coordination number of this complex? COEN thrice 3 plus. What is the coordination number? I think students, you are getting the answer very fast. It is 6, right? Because cobalt connected to En thrice. You know, 1 En provide 2 sigma bond. So 3 En provide 6 sigma bond. Coordination number is 6. On adding silver nitrate solution to 1 mole of this complex, palladium Cl2,4NH3, 2 moles AgCl form. I told you 2 mole AgCl formed mean 2 chlorine should be outside. Okay, the secondary valency of palladium in the complex will be, what is the complex formula given? Palladium Cl2,4NH3. When they treated with the silver nitrate, they are getting 2 mole AgCl. 2 mole AgCl formed mean there should be 2 chlorine outside. So what is the formula? PdNH3 4 times Cl2. 2 chlorine should be outside. Correct? Finish. Now the question, what is the secondary valency? What do you mean by secondary valency? You know, primary valency gives the oxidation state. Secondary valency gives the coordination number. So they are asking you coordination number. Here, palladium connected to 4 amine. You know, amine is a monodentate ligand, right? So 1 amine provide 1 sigma bond. So what is the total number of sigma bond here? 4. Now, which metal is present in vitamin B12 cyanocobalamin? Already they given the name cyanocobalamin. Cobalt. Cobalt is the metal present in which one? Vitamin B12. Fe3 plus cation gives a Prussian blue precipitate. Prussian blue precipitate on addition of potassium ferrocyanide solution due to the formation of. We discussed the application of coordination compound. the qualitative analysis. How they are checking the presence of Fe3 plus ferric ion, my dear. They treat the compound with a ferric ion with a compound we studied in class K4FeCN6, potassium hexacyanide of ferrite 2. And that will give you a Prussian blue colored complex. They are asking you the formula of the Prussian blue color. Fe4, here you are getting K4, here you become Fe4, FeCN6 whole thrice. This is the Prussian blue colored complex. If you are getting this Prussian blue color, you can confirm that the given compound contains ferric ion. So where is that? Fe4, FeCN6 thrice, yes. Okay, so and I think one more thing you studied that nickel presence, how you find nickel react with the DMG, dimethyl glyoxime, you will get a rose red precipitate, right? Rose red precipitate, you will get it, which indicate the presence of nickel. We studied under qualitative analysis. Hope it's, I think, the almost area of the chapter coordination compounds we completed. Study thoroughly the entire concepts once again, especially IUPAC naming, Werner's theory, VBT, crystal field theory, color, the metal carbonyl cases, isomerism, and which will conduct more electricity, the wavelength questions and all, energy relation with the wavelength. Study spectrochemical series, the application of coordination compound, and then go for your examination. Everything will be all right. So please practice the theory once again first, then go to the questions. All the best.